All right, cool. All right, so this is How Math Became Reality, a comprehensive look at the history and classical experimental evidence that's put forward in support of relativity theory. So, for the abstract, we have special relativity and general relativity defined. A quick summary of special relativity is that it's a theory to derive to explain motion and acceleration, and it proposes reference frames as a mathematical solution to describe the different, what would happen in, different relative motion. What an observer would see in this reference frame and that reference frame, right? So, and then general relativity was to bring in the concept of a gravitational field and equate that to the same thing. And a gravitational field is a mathematical concept that uses vectors to indicate a direction of intensity and or distribution of the force intensity as a force to describe the phenomenon. So it's useful for modeling, but it doesn't provide an underlying mechanism for the phenomenon, right? So anyway, that's what these two theories are about, right? So it's merging abstract mathematic concepts to explain natural phenomenon. In the history of relativity theory, so this presentation is primarily covers the general theory, but towards the end there'll be some association with the special theory. And to be clear, they are mathematically linked through the equivalence principle, where a gravitational field, the effects of being within the proximity of a gravitational field, are equivalent to what you would experience with uniform acceleration, according to the math, right? So for the general theory, when it was first being established as like the new framework to move forward to explain everything, um, they had to present like some experiments, some validity for relativity to overcome or whatever, right? So they have the perihelion precession, and the deflection of light with by gravitational waves and gravitational redshift. So these are the three core things that they say are what proved relativity and what was like the tipping point for this is more than just a theory, and these are this is what we're doing with physics moving forward, right? So we're going to go over the experiments put forward to give confirmation for these, right? And before we begin, sorry, did you have a question or something? Someone's mic was going off.
Yeah, I'm sorry. I was testing the overlay in the stream. My bad, dude. I didn't know you noticed that.
Oh, I got you. Yeah, you're good. Okay, so before we begin, we're going to go over a couple of prerequisite terms so we can get the terminology down and get the definitions defined and all that. So a lot of these measurements are done in arc seconds. So define what that is. If you look at a protractor and you have you look at the distance between 1 and 2 degrees. If you were to break that down into 60 sections, you would have um, 1 arc minute per section, right? And then if you break each minute into 60 seconds per minute, you would have 3,600 of those sections. So you can break down a fraction of a degree when you're talking about something in the sky to 1/360th or 1/3,600th of a degree. And then for the milliarcs and microarcs, um, those are typically done with what they call like satellites and stuff like that, where there's no atmosphere refraction and all that. So when they get with those measurements, that's what they're talking about with that. But it's the same scale, just applied smaller. So um, so more prerequisites. So we have some more terminology we're going to go over. So space-time, metric tensors, geodesics, and transformations. So the geometry of space-time is described by a mathematical construct called a tensor. Basically, it's just a way to describe a coordinate system. So it's just defining the boundaries of space time, essentially, just wrapped up in a neat package. So with that framework, you can use it to describe a Cartesian coordinate system. Let's see, and so for the space time coordinate system, they just added the time axis to the coordinate system, so x, y, z, t. So they put the time axis perpendicular to the x-axis. So your x-axis will be your axis of direction, and then the time axis, they sometimes refer to it as the world element or line element or world lines. That's what they're referring to. It's like a hypothetical axis that's perpendicular to your x-axis. So, what's the usefulness of this type of mathematics? How does it apply? Is it real? What does it mean? Who uses it? So, in the case of engineering, say you wanted to describe an I beam, for example, you could describe any point in this I beam with a with tensor calculus using like the using those metrics to define the coordinates of the I-beam, and you could show a relationship. So say you wanted to say how much stress is the I-beam experiencing at this point compared to this point, and you could express that entire relationship, and you could impose conditions on the coordinate system. So you could say like, it has this much weight on it, so it's experiencing this much stress. It's made out of this much material, so it has this much resistance. It's exposed to this much heat. Blah blah blah. So you can really um, you can really get specific with the math and the variables and stuff, and it has real practical application that you could use to apply to describe things. So for some more metrics, for some more terminology, we have the Schwarzschild metric that's used to describe space-time outside a spherically symmetrical, non-charged, non-rotating mass, such as a black hole, which is typically what they use to describe space-time curvature due to the mass or due to the mass of an object. It describes the space-time curvature due to the mass of an object and the motion of another massless object traveling through that curvature of space-time. So when an object is traveling through space-time, I forgot to cover this in the last slide, it's traveling on a geodesic, which means it's traveling in a straight path. And then space-time is obviously curved due to the intensity of the gravitational field. And when an object is traveling on that, on its respective geodesic, it's actually traveling along the curvature of space-time that's influenced by the gravitational field. So that's what they would use to describe a stationary object and something traveling through it like that. So the Kerr metric would describe, which is basically the inverse of that, where it describes two bodies in motion that have charge potential and all that. So it just and the reason for that is energy is equivalent to gravitation and all that in space time, or in Einstein's metrics. So if it has rotation or charge or whatever, it's going to have a different type of amount of curvature for space time. So that's the difference there. And then they got the FWR metric or FRW metric, which is for describing the large scale framework of cosmology and all that. So just like when you're talking about different scales of the universe, you can insert a different metric is basically all it is. It's basically a plug and play system where whatever you need to describe, there's a tensor already made for you, and however you need to apply the laws of physics, there's a tensor made for that as well, and you just combine them all conveniently. So you get into your curvature tensors, which explain how space-time is going to curve in proportion to the conservation laws and stuff like that. So everything is going to be explained through those. And for spectral shift and spectrographs, when you're talking about spectral shift readings and red shift and stuff like that, what you're looking at, or what, a good example of that would be, imagine you have a telescope here and there's a light or a star here. You're looking at the starlight, it comes into the telescope, it hits a prism, gets split into a rainbow so you could see it, and you're looking for slightly more red in the rainbow or slightly more blue. Very simple concept to grasp with that. And then they correspond those colors with motion, right? So if you're seeing more red shift, they're going to interpret that as something moving away from them. And if they see more blue shift, they're going to interpret that as something moving towards them. So there's a quick video here that I'm not going to play. I'll just briefly explain it on the Doppler effect and how they interpret that with the shifts and whatnot. So we have a stationary observer here. We have a moving car here, and it's honking its horn. So the sound waves are coming towards the observer through the medium of air, which is water vapor and oxygen. And those waves are vibrating right in the medium, and it's also being compressed by the medium that it's traveling through, and that compression is causing that high pitch that the observer hears as the car is going towards it. And that mechanism of causing the high pitch is facilitated by that medium, right? And then as the car moves away, the waves expand and they get that low pitch. And again, the medium, the density and everything of the medium is what's facilitating how how high that pitch, how you get that and how low it gets and all that, right? So the wave interaction with the medium is what produces the interaction for you to be able to discern the difference in relative motion. So when they apply that, they're applying a similar concept to starlight, right? So the red shift would be the car moving away from you, and the blue shift would be the car coming towards you. So for standard observational conditions when looking at objects in the sky with a telescope, we have a quote from McRoberts from 1995 from Sky and Telescope magazine, who says, Viewed at a high powered from a bottom of our ocean of air, a star is a living thing. It jumps, quivers, and ripples tirelessly or swells into a ball of steady fuzz. Rare is the night at most sites when any telescope, no matter how large its aperture or perfect its optics, can resolve details finer than 1 or 2 arc seconds. More typical at ordinary locations is the 2 or 3 arc seconds of viewing or worse. So there's the range of the optical or average viewing conditions. So if you remember back to the arc seconds here, the fractions of a degree for the arc seconds. So on average, they're saying you can see like 2 to 3 of these bars. And then a lot of the measurements that we're going to be looking at are actually, sub 1 arc second or, 1 arc second, right? Let's see here. Okay, so to get into the proofs that they put forward for the general theory, we'll start with the perihelion precession with Mercury. And there's nothing too fancy here. The previous Newtonian theory of gravitation that they were using to explain the solar system apparently was unable to predict, under the Newtonian framework at that time, was unable to predict the perihelion precession observed by Urbain Le Verrier over the course of like 40 years. And then he mathematically extrapolated that if the precession continues over the course of a century, Mercury would precess by 5,600 arc seconds. So going back to that scale again, 5,600 arc seconds would be about a degree 0.25. So a degree and a quarter. They're saying over the course of 100 years, Mercury will shift in the sky by a degree and a quarter. And Newton was unable to explain that to the full degree. He could only explain 5,557 arc seconds per century, and Einstein was able to come up with the full effect. With the concept of space-time curvature and gravitational fields rather than mass attracting mass. And so let's see. There's nothing too crazy there. It's just a calculative prediction. So to give a representation of what that looks like, I drew this on paint. So here we have the sun. Here's the equator of the sun. Here's Mercury. Let's say every year that it goes by, it just moves up slightly. So over the course of 100 years, it moves up by 1 pixel. And Newton's theory was only able to explain a half pixel shift, while Einstein was able to explain the full pixel shift of Mercury, if that makes sense.
I don't know if it's just me, or is it unstable internet cutting off your presentation? Oh, it's back now for me. Was that just me?
You sounded really laggy when you opened up and we're talking, so it might have been just you. Is it good on everyone else's end, Shane?
No, I just got
No,
unstable internet myself right now.
Yeah, your
me
cam is
too.
kind of buffering in and out on Discord. I don't know if it's us or your internet.
Yeah, it's definitely my internet.
Yeah, it's spotty for me too.
Okay. Let's see.
It's not terrible though, dude. It's not terrible.
Yeah, it's not terrible. You want to drop it to like 720, 30? Is that what you're at already?
Yeah, so this is just from my cam, so I can change it to a regular presentation.
I meant like stream quality in Discord here for us to see it, because that's all we see, right? Is your Discord output from the server?
It's from my cam quality though, so like it's already just gonna be 1080p, I think. So I'll change it to the presentation type and lower it. So how's that?
That's good.
All right. Cool. Is it clear enough?
Yeah, it's super clear.
All right, cool. Sorry about that. I apologize. Thank you, Dave, for clearing that up. All right. So let's see here. So picking up. So for Einstein, so for the perihelion precession, this problem or whatever so-called was known about for a while. In 17 years prior to Einstein's explanation, a man named Paul Gerber came up with a solution and a mathematical equation to explain it, but just under a different mechanism. His mathematic equation was representative of saying that that the disturbance was caused by a perturbation of a gravitational wave, and the speed limit of that wave was set by the ether, and that was and they had already moved on from the ether, so his explanation wasn't accepted as a viable explanation for Newton. So Einstein came along and used the exact same equation and just changed two symbols in it. The T symbol here. So what Einstein's contribution to the equation was, is he said, instead of taking the speed limit for C, all we need to do is take the total time of the orbit, like the time, right? And then just contract that. And with that contraction, we can make it meet C to get the prediction. So that's all he did, is like this capital T and this lowercase t. That's all the difference he did between those, is he just contracted the coordinate system to meet C. So that was his mechanism, and that was viably accepted. And then when called out for this plagiarism, Einstein's response is he says, how could I have stolen from Paul Gerber if I have never seen his work? Just trying to downplay it or whatever. Even though he has a long history of plagiarizing things. And like, for example, prior to his 1905 publication of Special Relativity, he says that he had, the way that he talks about the Michelson-Morley experiment is like he organically heard about it on his own, and he just decided to come up with the theory, or based on that in the moving of dynamic, or the movement of magnets in capacitors, right? It's like that was his thing or whatever. But a couple years before he published that, he wrote to his wife in a private letter stating that he basically was going to study Lorentz's ether contraction explanation for the Michelson-Morley experiment and moving bodies and magnets and all that. And and he was really interested in it, and he was going to get back to her. And then a couple years later, boom, Special Relativity comes out, and it's based on Lorentz transformations and adheres to Lorentz symmetry and all that. So, and he gives no credit to Lorentz in his published papers for his special theory. So, like, taking him on the face value of, did he just rip off Paul Gerber's explanation? Like, you be the judge. But yeah, these equations are identical, and the explanation is only varied by accepting the fact that the time would, it can vary, right? That's all he changed to facilitate the mechanism to describe the perihelion precession. So let's see. All right, so for the Schwarzschild metric, so again, after the Paul Gerber stuff, using the Schwarzschild metric, the perihelion precession was also derived, and I kind of wanted to give a little preface on the Schwarzschild metric and talk and just kind of showcase how that works and where they, what they're doing with this equation and what they get out of it. So again, with the Schwarzschild metric, they're imposing ideal conditions where they're, like, for example, with the sun, they would say it's stationary, non-rotating, has no charge or nothing like that. And then Mercury has no weight, and it's traveling in a straight line that's curved due to the sun's gravitational potential based on the conditions imposed on it with the metric used to describe space-time. So to break down what all this means here for the equation, we got the space-time interval. So this ds squared, this is the space-time interval, which describes the distance between two events, and it basically defines the geometry of space-time. And we have this little piece here, this 1 minus g, or 2 gm over rc squared and all that. So this factor is used to describe time dilation in gravitational redshift experienced by an observer in a gravitational field due to the curvature of space-time. So it relates to the frequency of light. So when they're looking for a frequency shift or redshift and all that, and they corresponded to a certain frequency and whatnot, like they get that out of that equation. So dt is your time coordinate, and r is going to be the change in the radial distance between two events in space-time. So it's just establishing a coordinate system as well. And let's see, this one's going to be the factor reciprocal of the above, describes the gravitational effect of the two coordinates. So it's just describing that stress relationship, like I was saying earlier, how you can have two events and describe the relationship between them. Your d theta represents the change in the polar angle. So it's just basically calculating angles for everything, between two spheres. So the top of the sphere and the center and all that. So that's really all they're doing with it. Pretty straightforward with the rest of that. And I already covered how they, impose their ideal conditions for it. So when they get their calculative results out of that metric, like that's what they're doing that's what they're doing with it, and that's what it means to calculate with it and get answers out of it or whatever, right? All right. So for the perihelion precession, um, there's lots of explanations for what could be going on in the sky. Is this calculative answer an actual proof of the theory? No, it's not. And everyone already knew that. So they were just trying, so to continue on, there was additional supplemental evidences that had to be put forward for the theory. Oh, it says, "Hey Shane, you might need to reshare or write or reconfigure OBS." Um, Mrs. Tribune says that she's not able to see what we're seeing.
Oh, what do you mean? No, that's fine. You were showing that last thing for a really long time, though. Maybe she thought, because I thought maybe you didn't know. Is that like the math numbers going over and over and over and over again for a while? Like your slide now is visible to everyone, so I don't know.
Oh, okay. Yeah, I'm on a different slide now. I'm on the deflection of light rays. Is that what you
Yeah.
say?
Yeah.
Oh, okay. Okay. Never mind. My bad. Okay. So the next supplemental evidence put forward is the deflection of light rays. So we're going to get into gravitational lensing and all that. Okay. Yeah, we're good, Shane. Thank you. So the deflection of light rays. So let's say we have a star here. We have a giant celestial body here. We got our gravitational field and our mathematical description of the forces of that gravitational field and the distribution of that field and how it impacts the space-time coordinate system. And based on that, a photon traveling in a straight line behind this sun will actually be traveling along the curvature of that space-time coordinate system, and we'll actually be able to see it, and then it'll be as if it were placed here. So when they talk about gravitational lensing and that and the deflection of light rays and with the Arthur Eddington experiment, that's the concept of what they're talking about. So here we have this gentleman, Arthur Eddington, who is credited for finding the first positive evidence of gravitational lensing. So this is Arthur Eddington, British astronomer, who led an expedition off the island of Principe off the west coast of Africa during the total eclipse of 1919 during May 29. The purpose of his expedition was to determine the accuracy of three theories regarding gravitational influence on starlight. So this was the Newtonian theory. So the prediction of starlight displacement was 0.87 second or arc seconds, and Einstein's theory was 1.75 arc seconds. So basically double that of Newton's predictions on how much starlight would have to move due to a gravitational field. And this was going to differentiate between, the concept of mass attracting mass and a gravitational field affecting space-time, and then something traveling in a geodesic having its path altered traveling on that curvature of space-time. Because space-time has to be a physical mechanism. So there's also a lot of contention, real quick, to get into a sidebar. There's a lot of contention about, you ask somebody what is space-time, and they either don't have a description, or they'll say, it's the fabric of space, it's the fabric of the universe. It's an abstract concept and whatnot, right? Well, the truth is that it is an abstract math concept, but it has to be given physicality for people to accept it, at least back in the day, before everyone, because the previous framework of interpretation was the ether, and everything is mechanical in that framework. So everything is pressure mediation facilitated by vibrations and vortexes and stuff, right? So everything in there is, connected, so to speak. So this idea of nothing being there and then nothing, like the abstract description of it, conforming, and describing reality, had to have meaningful experimental evidence. So this is a big step in proving the difference between, hey, this is just some blank sheet math where we can swap in different stuff and say whatever we want. Like, these are actual real effects and blah, 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 right? So this was going to establish like the actual fabric, right? The fabricity, if you will, of the universe, right? So with these two predictions, this was going to be the deciding factor. And then in combination with this, there were gravitational redshift observations, but those aren't talked about in the mainstream narrative. But in tandem with this starlight displacement observation, there was a simultaneous redshift observation that we're going to get into in the next slides. But for now, we're going to stick to the starlight displacement narrative. So this is just going to cover Eddington and the starlight displacement narrative moving forward. So the official narrative is that that Eddington and his boy Cromlin set out to their two respective places. Cromlin went to Brazil. Eddington went to Principe. and they both had 16 slides. So Eddington's slides, none of those were good. Only 2 of them turned out to be good. And then his boy Cromlin, they say due to a temperature differential when the eclipse happened, that his apparatus contracted, and unfortunately, due to that contraction, his measurements were not accurate. So they can't give any good predictions out of that or any good readings. So they don't use any of his 16 photographic plates. They're all rendered useless. So the only surviving artifacts at this time are 2 plates that Eddington examines on the spot and gives a quick analysis of them, and he thinks that these 2 are going to be the ones that give the positive confirmation. He writes a couple of people before he gets back, explaining all this to them about the 2 plates and whatnot. So that's the story moving forward, is that there's these 2 plates that give this successful confirmation of starlight displacement. Now, keep in mind, when most people think of starlight displacement, they say, like, imagine this is the sun. Well, so this is the sun right here, and these are different stars. So when you think of a gravitational field and displacement, you think that the gravitational field will displace, stars from all over, right? Because the field's massive, right? So like if you look at the gravitational field model of the solar system, the gravity well of the sun and all that, and the planets, like it, the well is the whole solar system, right? Basically. So you would think that there would be more displacement, in like close proximity to the sun and stuff, right? So what actually happened was they say that they only saw displacement within the solar limb of the sun. So we'll get into that as well. So we got 2 photographic plates, and we have displacement in a very specific area of the sun where there's already alleged to be a medium and stuff. So 6 months after the observations that Eddington took when he got back to England, and they did their analysis and stuff, it turns out that they couldn't use 2 of the reference plates either. So the before and after pictures that they were taken for the comparison. So they had to use reference plates that were taken a year earlier that were made of a different material and taken with a different setup and all that. So they had to come up with a way to, convert and all that. So after Frank Dyson Watson contributed to a statistical analysis, they figured that they got enough displacement to give the Einsteinian prediction. And on November 6th, this is where the Royal Society and Royal Astronomical Society got together to give their successful confirmation of Eddington's observations in saying that, the Einstein's theory was confirmed. So I go through the transcripts here for the next couple of slides, but it's kind of dry and boring. So I'll just kind of summarize I'll just kind of summarize them here. So Sir Joseph Thomson is the president of the Royal Society, and he opens the meeting by saying that Eddington made a successful confirmation and Einstein's the man, and he wanted to give everybody a high five. And then Eddington chimes in and he's like, yeah, thanks, it was great. He gives them a high five, and he gives a couple other guys high fives. And there was he raises a point about the because of the solar limb situation. So he just tries to kind of preface about the atmospheric conditions of the sun, so to speak. So on the solar limb of the sun, they assume that there's a magnetic field and an electric field and a plasma situation going on. So there's a medium there, right? So to separate any sort of displacement from these various mediums and stuff like that would be a high point of contention, because this is where the only stars were displaced. So Eddington makes a little preface here saying that what they know about the sun or whatever, that couldn't possibly explain it. The sun's atmosphere would have to be way more dense or whatever, right? There's a couple of pictures here of the slides. We have, so going through the transcripts again. So this guy, Professor Alfred Howler, chimes in, and he talks about, what does he talk about real quick? So yeah, he gives a brief summary on the spectroheliograph analysis. So this is in regards to the redshift analysis that we're going to get into here in a bit, that was going on in tandem. And he's talking about the 2 gentlemen that were doing observations to establish a redshift, to establish an actual cause and effect relationship, right? Because not only if there was going to be a displacement, there also has to be a frequency shift if there's going to be an interaction with space-time, due to the gravitational field and all that. So there's going to be a frequency shift. So there's going to be some redshift in that. So that's gravitational redshift. So they had people looking for that as well. And this guy makes a reference to that, and he's saying, "Hey, we've even been using spectrums of Venus, and they're showing no displacement. So like, I don't know, we should maybe like look into this a little further." So this guy like raises a little eyebrow at it, as a little critique to it. This guy chimes in favor of it. And so this guy talks about the atmosphere situation and all that. What they were talking about with the solar limb and the displacement. I'm sorry, with the redshift observations. And he's like raising some questions too, but he's like, congratulations on the successful confirmation. It's all good. So not giving like too much resistance. And so this guy, what he points out is really key to the issue here, because this in tandem with the knowledge of the gravitational redshift observations that are absent from this successful confirmation announcement. Dr. Silverstein says this, and I'll read this here and go over what it means and break it down. So it says, but in spite of what the president said, I believe this result to be essentially an isolated fact. There is a deflection of light rays, but it does not prove Einstein's theory. It cannot logically be deduced from his theory as a gravitational effect in absence of the spectroscopic results. And as we know, and as far as we know from St. John's and Evershade's observations, the predicted redshift of the spectrum lines of the amount exceeding almost 100 times the probable error of modern spectroscopes, as Professor Fowler has just told us, is not obtained. And Professor Lindman's attempt to explain the obstinate nullity of the effect by the motion of the luminous gases in the line of vision is not satisfactory. For St. John was well aware of such complicating circumstances, and therefore purposely observed as many as 43 lines at the sun's center and as many as 35 at the limb. Now, we cannot well assume that the gases move everywhere towards or away from us to suit Einstein's theory, i.e., just to compensate for his theoretical shift effect. As I have already pointed out on another occasion, if there is no spectral shift, Einstein's coefficient, which is described by spacetime curvature, so his G subscript UV is his spacetime curvature, which is entirely responsible for it, must be unity. So if there's no curvature to interact with, or if there's no redshift observations in tandem with this, then you can't establish that there's a curvature of anything that's traveling on. This is what he's saying. So, which is entirely responsible for it. It must be unity. And if we go back to the differential equations, Einstein's field equations, we see once that the coefficient of his well approximate solutions become unity at the same time. And he gives the equation for how they relate length and time, or time and what is it? Time and distance, how they're intertwined, so that the world element reduces to, and then he gives the equation there for saying basically it reduces to zero. So earlier I was saying they take the hypothetical time axis and they make it perpendicular to the direction of motion. So he's saying if there's no direction of motion, then there's no hyperbolic contraction relationship between the curvature of space-time and the curvature of space to proportionally meet C. So if that's not the case, if there's no redshift and there's no curvature and like none of this is real. So he's saying that all this just reduces back to nothing. And since the equations of motion are always given by, and then he gives the imaginary number equation equals zero, we ultimately see that the spectral shift is absent. Einstein's theory Einstein's theory not only does not give such refinements of planetary motions as in the secular motion of a perihelion, but not even in the ordinary Newtonian or Keplerian motion. In short, the orbits of the planets would be straight lines, and the planets would move along them uniformly in spite of the sun's presence. The theory stands or falls on the correctness of the results of Evershade and St. John. So again, that was that cause and effect relationship with the curvature, with the frequency. So back to that equation, how you can get the frequency shift out of that in tandem for how much space-time would have to be curved to facilitate the displacement distance, right? So all of that, you can get these predictions out of this equation, and they weren't matching observations by these two men, St. John's and Evershade, who were taking spectroheliograph observations. They were doing the the spectral readings. And they found that they could use Venus transits as well throughout the year, so they didn't even have to wait. Well, I'll just keep reading. He actually covers that. Sorry. So we're all caught up on that. So it is unscientific to assert for the moment that the deflection, the reality of which I admit is due to gravitation, in this sense that I declare it a moment ago to be an isolated fact. The discovery made at the eclipse expedition, beautiful as it is, though not in this circumstance, or does it prove Einstein's theory. We owe it to that great man over there, pointing to Newton's portrait, to proceed very carefully in modifying or retouching his gravitational laws. This is by no means defending blind conservatism. The spectral shift required is perhaps 100 times, but certainly not less than 40 or 50 times the error of modern measurement. The solar spectrum can, even in this country, be observed many times a year, and the matter can thus be decided without having to wait for an equally advantageous eclipse, or having to wait centuries for an eclipse. If the shift remains unproven at present, the whole theory collapses, and the phenomenon just observed by the astronomers remains a fact awaiting to be accounted for in a different way. So that was his analysis of everything so far. So before we continue on, does anyone have any questions? I know we've been over a lot of concepts, and I kind of forgot to stop for a second. Does anyone have any questions or anything? All right, cool. We'll continue on. So in response to what Silberstein says, Eddington's response is one word in reply to Dr. Silberstein. When a result that has been forecasted is obtained, we naturally ask, what part of the theory exactly does it confirm? In this case, it is Einstein's law of gravitation. It is not necessarily his theory that is confirmed, with the underlying assumption that ds is a quantity measurable by clock and scale. There still remains the question of the intermediary of what ds is. So like what the fabric of spacetime is, right? Is what he's saying there. Which must be tested by the Fraunhofer lines, and the Fraunhofer lines are in regard to the spectral readings. So when you look at let me go back for a second. So, that's way back. All right. So your Fraunhofer lines are going to be right here, like these displacement lines in the readings. Your emission lines, that's what they used to call them, Fraunhofer lines. So when they're looking for those spectral readings to correspond to a cause and effect relationship with the description of a coordinate system conforming to meet C, they're looking for that relationship where they can extrapolate from the spectral readings that, oh yeah, light did change, it did interact with the gravitational field, such as predicted by the equations that describe it, right? So, so Eddington's just claiming here, like, hey man, it's all good. Like, we got a successful prediction. Like, let's not press the matter. And I didn't include this in the presentation because I'm super lazy. But Eddington wrote a letter to Hermann Well, a Swiss mathematician, 6 months prior to the Eddington observations, where they had actually been those St. John's and Evershade gentlemen had been doing gravitational redshift observations for months prior to the eclipse. And they consistently got nothing corresponding to what would give an agreement with Einstein. And Eddington was super worried about that. He reached out to Wells saying, hey man, you got this new theory coming out, this new unified theory. We're having this gravitational redshift problem. Einstein's theory is not successful in that. St. John's and Evershade aren't willing to play ball. And it's kind of putting it down. They're being kind of downers to the group, and maybe you can help us out with your theory. So he was already reaching out for an explanation. So like the way he downplayed it at this conversation, as if he didn't realize the significance of what Silberstein was saying is like really disingenuous. And this can be read in a paper from John Earlman and something Gilmore on the redshift analysis or something like that. I'll have a link for it later. But sorry, I forgot to include that. But just a short history on that in Eddington. So he was already looking to jump ship because Einstein's theory was already mathematically failing, and obviously with the special theory failing with the different interferometry tests that were coming out showing a varying speed of light, it was getting hard to co-opt all these things. So they had to really rush this theory in, and Eddington was starting to feel the heat of that. So November 7th, the very next day, the British media and U.S. media successfully announced that Einstein was the man, and Eddington proved his theories and all that, and the starlight displacement. So now, when nowadays when people are talking about starlight displacement, like that's the full extended story of it. That we don't really know about. Like most people conceptualize. I know I speak for most people, but the way that I conceptualized this gravitational situation before I looked into it is that there was starlight displacement, within like the proximity of the sun, not within where they already assumed there to be a medium or anything like that, and like such a minuscule displacement and all that. So here's a couple of analyses of the Eddington observation and subsequent observations done after. So this is from H. von Klubber, 1960s in Vistas in Astronomy. It says it should be noted that the deflection predicted by Einstein in 1916 was very small, being about 1.7 seconds of arc of a ray of light at the edge of the sun, and inversely proportional to the radial distance of the center of the sun, since no star for which the measurements were made during the 1919 eclipse were within 2 solar radii of the center of the largest, within the 2 solar radii of the center. The largest deflection that would have occurred to the theory would have been less than 0.8 seconds of arc, which which for the 343 centimeter focal length of the telescope used by Eddington would have corresponded to about 0.01 millimeters, or 0.00039370008 inches on the photographic plate. So the effect measured and seen wasn't even so remember remember Newton's prediction was like 8.7 or 0.87 arc seconds. So like the prediction was even closer to to Newton's displacement than it was, but again with the mathematical corrections from Frank Dyson Watson and the successful confirmation by all these prestigious men and the media and everything, like they just moved forward with this story, like they just rolled through and saw some actual displacement of anything. So this is Dennis Sima from 1967 in a book titled Einstein, the Man and His Achievements. The first attempt to test Einstein's prediction was made by British expedition led by Arthur Eddington just at the end of the Great War, at a time when it was considered very striking that a group of British astronomers should attempt to test a theory proposed by a German. The results of the test were claimed as a triumph for Einstein, and his worldwide fame dates from this event. Ironically, enough attempts have been made at later eclipses suggesting that Eddington underestimated the uncertainties inherent in such difficulties of observations. And even today, there's predictions. Einstein's predictions have not been tested with the precision one would wish. So, going not to dwell back on the history of the Eddington observations, but there was a lot of problems with it. So, like I said, they chalked that one guy's entire observation up to a temperature differential and say that they couldn't even use that. So there was just a lot of stuff going on, and then so subsequent observations haven't gone well either in terms of providing a successful confirmation of providing supporting what Eddington put forward. And this is John Maddox, Nature Magazine, 1995. Historically, the most dramatic proof that Einstein was on the right track with his general theory of relativity came in 1919 when Eddington and his associate Cromlin took themselves to the western Pacific to track the total eclipse of the sun of that year. They were bent on measuring the predicted deflection of light from distant stars lying near the limb of the sun. And as the world knows, the prediction was confirmed within the limits of accuracy for the observation. To general applause, Einstein became a celebrity overnight. What is not so well remembered is that the measurements in 1919 were not particularly accurate. The standard error of measurements was roughly 30%, while the displacement of the images of the different stars in the field near the eclipsed sun ranged from half to twice the deflection that Einstein had predicted. The later eclipse measurements have not been much better, largely because the difficulties in making accurate measurements from the ad hoc observatories that have to be established at the locations where you're going to, be, in that alignment, right? So this is from Edward Dowdy here. So this is a plasma cosmologist, and the reason that some people become plasma cosmologists, this is a highly educated and decorated man who changed his cosmology from relativity theory, former NASA employee and all that, became a plasma cosmologist because when he looked into the Eddington observations and all that, he realized that there was no displacement in the way that he also conceptualized the displacement before he looked into it. When he realized that it was within the solar limb and that there was, a plasma could explain it, that was a big pivotal tipping point for him. And you could find his interview on the YouTube channel called Sky Scholar, and just type in Edward Dowdy on the search on their playlist or whatever, and his video will pop up. It's an interesting interview. I mean, he wrote a couple of papers on all of that. So just to give one more reference to the sort of displacement. So starlight, you would think that starlight displacement would happen from a big gravitational field all over, but it really only happened within this select area where there's different, could have been anything, right? Let's see. Okay. Okay, so in conclusion, from the mathematics that are used to describe everything, when the experimental evidence doesn't work out, they just don't talk about the experiments. So we went over the gravitational redshift a little bit in regards to that experiment. So they totally prop up this observation experiment as if it wasn't completely undermined by the gravitational redshift observations that were going on in tandem. So so they have no cause and effect relationship for any displacement, if any, and no one really has done any subsequent observations that could back up what they say happened. So to get into gravitational redshift now, we're going to get into those effects. So light and how it's in its interaction with gravitational fields and space-time curvature. So there's different types of redshift. There's gravitational redshift, where the wavelength of light from an object is shifted towards the red end of the spectrum as it travels through a gravitational field. This effect is caused by the fact that the photons lose energy as they move out of the gravitational well. This loss causes the wavelength to stretch to compensate. So remember, the speed of light is always the same. So to compensate for the energy loss, there's a stretching, and the stretching is the amount stretched, like frequency. All of that will be is predicted, from those equations that we talked about earlier. So all of that can be derived from that. So cosmological redshift. So wavelength of light of an object is shifted towards the red end of the spectra due to the expansion of the universe. This is caused by the fact that the universe is expanding, and therefore the distance between the two, the source and the observer is increasing. It's changing. So the distance, that relative motion, is causing a stretching, or is causing a change in the wavelength of light, which stretches it, which causes redshift. So that's their interpretation for cosmological redshift. So when they talk about, Hubble shift and everything's moving away from us, and the bread rising or whatever, the raisins and all that, that's what they're referencing. So the transverse Doppler effect. So this is a phenomenon in which the frequency of a wave appears to be shifted towards the source, or shifted when the source and the observer are in motion to each other. So this was so they kind of equate this to like a time dilation effect when they for a certain type of Doppler shift, for a certain spectrum shift in light. So in summary, in general relativity, there's different predictions that can be made due to the curvature of space-time, based on the presence of the objects in it, and the interaction with light, with the interaction with that gravitational field based on the presence of the object, right? So other types of redshift. So let's see, Doppler redshift, so caused by relative motion between the source and observer. So time dilation redshift. So that's in more regards to the transverse Doppler effect, or the relative Doppler effect. I forget how they word it. It's worded a couple different ways, but that's the time dilation redshift type thing. So the gravitational lensing. So that would be an effect in tandem with this redshift. So that would be where there's an actual displacement of that. Let's see. And then so Hubble, proposed that everything was expanding away, but even up until his final lecture at the Royal Society, he always held that there was a possibility that he was interpreting it wrong, and that the velocity recession that they're observing might be due to something else. So I just thought that would be a nice point to include there. So let's see. So for gravitational redshift, they're in back in 1919 with the Eddington experiment. There hasn't been any gravitational redshift to supplement the starlight displacement, right? So they were looking for another way to test this. So in the 1960s, they did the Pound-Repka experiment. Two gentlemen got together at Harvard's Jefferson Tower, a 22-meter tall structure, and had a photon emitter at the top of the tower and one at the bottom, and they emitted photons from the top and at the bottom, and they measured the frequency shift, um, at the top and at the bottom, and they were looking for relativistic predictions, right? So there's a couple different explanations that are given for this experiment. It didn't give a. If you go to like Wikipedia or whatever and you type in, proof of relativity theory, the Pound-Repka and Pound-Snyder experiment will be on the proof of the theory, but it didn't give a positive confirmation of the theory. And even from the two papers that these gentlemen published, they make note of that. So we're going to read a little bit of their papers before we get into the relativistic interpretation of these experiments as to why people interpret them as giving confirmation of the relativistic theory. So this is from the effect of gravity on gamma radiation from Pound and Snyder. So this was the follow-up experiment from Pound-Repka. Same situation, just in a taller building. That's the only difference. So they recap a little bit from their first paper. So they say their first paper was titled "The Apparent Weight of a Photon," and their conclusion from the first paper was that the effect of gravity was as if it was pulling the photon faster, so that it was so like it got there a little faster, and they didn't quite know what to make of that because in relativity theory, the speed of light should be the same and all that. There shouldn't the light shouldn't change in that way. So they said, so the title was "The Apparent Weight of a Photon." And then so that's what they're referencing here. So they say, "It is not our purpose here to enter the many-sided discussion of the relationship between the effect under study and the general relativity or energy conservation. It is noted that strictly no relativistic concepts are involved here, as the description of the effects of an apparent weight of a photon is suggestive. The velocity difference predicted is identical to that which a material object would acquire in free fall from a time equal to that flight time. So the distance travel time, it's as if it acquired, a 9.8 meters per second squared increase, right? So, and then they go on to try and say maybe the rotation of the Earth had something to do with it, but they, it didn't. So that wasn't able to give an explanation for it. And then they close on this. They say, "The view that the local timescale depends on gravitational potential appears to require a coherent source for confirmation. The present experiment is unable to distinguish frequency change and velocity changes. For example, it appears as if experimental comparison of clocks at different potentials would make a useful complementary contribution to the overall status of relativity theory." So what they were saying here is they were unable to establish between relativistic effects due to the interaction of a gravitational field and space-time curvature and relative motion through classical mechanics, and that maybe they should do an experiment with synchronized clocks, which we'll get into the Heffel-Keating experiment as we move on. So with no successful confirmation of the theory alluded to in these papers provided by these gentlemen, how do the relativists interpret this experiment as successful confirmation? So there's a couple different ways, which they're kind of lengthy, but I'm not going to get into all of them. The most common one that they do is they say, where's time dilation at? Yeah, okay, so they typically go with time dilation. But someone generously calculated everything out for me. So if you if you give them the benefit of the doubt on the gravitational potential in an object and all that, and the shift, time dilation effects would be into 2.7 times 10 to the negative 21 effects, right? And then the pound rep experiment itself was measured in the 2.5 times 10 to the minus 15. So any time dilation explanations would be well outside of the outside the abilities of, the immeasurable capabilities of what these gentlemen had going on to give an actual explanation. However, you can calculate the effect out, and that calculation effect is what people generally say, because it can be calculated, they interpret that as like a true meaningful thing, but it's not even within the scope of the experiment to produce a visual effect that would have affected anything. But that is the most common explanation for it. So to give a quick explanation on what also produces redshift in light is the Stark effect and the Zeeman effect, respectively. The Stark effect is an electric field, and when there's electromagnetic propagation going through the field, depending on the density of the field and the direction of the current flow, that will affect the light spectrum, in a way corresponding to like if it's going upstream or downstream, right? So it's going to slow it down or speed it up, and so to speak, and that's going to cause a frequency shift, and you're going to be able to get readings out of that. And let's see. So the Zeeman effect is the same thing, but with a magnetic field. So the density of the field is going to be it's going to dictate what kind of effects you can, the strength of the effects that you can get out of that. So these are known effects that produce the same spectral readings that they're reading, right? So when they take emission readings and they're like, hey, this could be, this is this gas because this line's missing. So it means that this element is in the atmosphere or whatever, right? So when you're looking at when light's passing through an electric field or a magnetic field, well, what can happen is that there can be a splitting effect, so to speak, where their end result was it'll just create lines where it'll make you think like, hey, this element's present in the readings, but it's not, or it'll make you think, oh, it's shifted this much red because of this factor, but like you didn't account for the magnetic field or something like that. Like it can produce all of those effects. So we'll get into some demonstrations of those by the homie Ken Wheeler, who demonstrates electromagnetic retardation. So when an electromagnetic wave propagates through a field, it experiences retardation. So that frequency shift where it gets stretched or compressed or expanded and all that, that is electromagnetic retardation. That's what that's called. So Ken Wheeler has an excellent video on that I'm going to play through. Let me reshare this to make sure that the audio can come through. Actually, I think I shared it right. Let me know if you can hear the audio on this real quick, Shane.
I've made so many discoveries in magnets.
Good. Okay. So
Roger.
Okay. So we're gonna watch a little demonstration of redshift and relative motion shift with a magnetic field, demonstrating the shift based on a magnetic field. So you got the timestamp here. Just give me 1 second. All right, take it away, Kenneth.
Slew. But how can I shift that? Relative motion to the disparity of the electricity, i.e. light, which is a coaxial circuit, transverse electrical magnetic.
I'm sorry, to preface real quick, he's got a neodymium magnet here under this ferrocell. And what he's looking at is a holographic projection of the ferrofluid with in between the lenses there. So he's got like a what do you call it, like a castor oil type solution, right? Like just an oil lubricant, and then some iron filings, where you can also use a drop of your blood and use the iron in that, which I think that's what he uses in that. So that produces a hologram of the magnetic field, and that's what we're looking at. So sorry, go ahead.
What did you say goes through the magnetic field and experiences the EM retardation? A photon?
Any electromagnetic propagation. So like
anything.
Yeah.
Okay.
Yep. So we're actually going to see what that looks like in real time, right? So I'll let Ken take it away.
Longitudinal dielectric. Let's show you phase shift. Now look closely and I'll explain it. You see how this is blue now? As it was approaching, it went to blue shift. If I move it away, let's just look at this one pole only. Let's ignore this pole over here, okay? You notice that this red shifted now? Let me move this closer to a person over here. Let's say there's a person on a little planet over here, and this is a star. Okay, now it's red shifted. Let's move this star closer to this person over here. You see how this blue shifted? Let's move it away and watch this blue, which is bluish green, but it's still blue shifted, turn to red. Red shift. Blue shift. We're only looking at this pole over here. A second. I think I had a little power outage there. There we go. Blue shift. Red shift. Red shift, moving away from this relative point. Now let's take a look. Let me check my power connection here. Let's take a look at the other pole. A second. There we go. Sorry about that. Let's take a look at the other pole over here on the right side. Let's orientate my magnet exactly. Okay. Let's wait for it to appear. There we go. Let's take only a look at this. Blue shift relative to this person over here. Let's say this point over here. Blue shift. As it moves away relative to this point, we have red shift. You notice how it shifted to the red? Now watch it shift again. Remember, we're only looking at this pole on the right side of my finger. Okay? Red shift, blue shift. Red shift, blue shift. Inverse to the other pole. Look closely. Nothing has changed other than disparity of EM retardation. It has nothing to do with space, has nothing to do with time. It is EM phase shift disparity, or EM retardation.
So the frequency of light that's propagating in there is being affected by the magnetic field, and if it's traveling with or against it, that frequency shift is producing a color, what's it called? Color shift. So that's why you're seeing that red and blue shift switch there. That's what's producing that electromagnetic retardation. So if there was like an experiment that somebody could do where they could have a space-time magnet over a ferrocell and produce something like that would be an awesome way to demonstrate a cause and effect relationship with light in a medium, or an abstract hypothetical description of a medium that may or may not be interacting with a photon, with an alleged photon. Sorry, was there a question? I heard someone's mic going off.
Have you heard the opponents to this specific video from
Well, I'm sorry, say that again.
him? Have you heard people that strongly disagree with his interpretation of the phenomenon that we're witnessing there?
Oh, yeah. So even if I played the video on mute and like we didn't hear anything he said about how a magnet works or his interpretation, the effect still persists. What he demonstrated, even though he doesn't know it, is the Zeeman effect. That's exactly what would be what's already like established as something that would happen. So this would be like a demonstration of the Zeeman effect, right? The electromagnetic retardation causing a phase shift in light. Yep. Yeah, so I usually actually preface that because a lot of people don't like Ken Wheeler, and they're like, they hear Ken Wheeler and they're like, oh my God, no, I can't. So I usually preface that. So thank you for bringing that up. I forgot to preface that.
They hate on that video right there. They really try to say he's false analogy. Like I think he tries to apply that to the redshift out in stars in space, and they don't. A lot of people don't like it. I don't know about it. I'm a reporter.
Well,
thank you.
Yeah, no. So that's really interesting because actually recently Witsit pointed out an article where an astronomer was saying that they made some prediction and they were off because the star's magnetic field caused the redshift, which was a glaring omission because they don't really talk about the effects of because all these planets and stuff have magnetic fields and whatnot, right? Or most of them do anyway, but they never really talk about that or make any sort of corrections relative to what that would produce. So they attributed the whole effect to the planet's magnetic field, and it's like, oh, dude, so are we going to reanalyze everything now, or just this one time? That's why they don't want to talk about it, because it's too much extra stuff for them to deal with. Because a lot of so-called relativistic effects, the behavior of light, basically, is explained through electromagnetic retardation and just like an interaction with the medium. Like, so they're all inseparable from classical mechanic effects, right? So anything where they're like, oh, there's a shift in the light, it changed. Well, like that's all facilitated by a medium inherently. So the trick here was to convince people that this shift would happen if you move this ferrocell over nothing or over a so-called gravitational field.
I'd love to learn more deeper about it, which you later, but I won't.
What's that?
Obviously, you got a whole. I'd love another time to go over this one thing specifically. I can learn more about it from you, probably.
Okay, cool. Yeah, we can come back to it or something later. So here's a cool video from my buddy Shane who shows this magnetic vortex situation. Oh, sorry, I skipped ahead a slide. So let's see. So there's a lot of speculation on where we live and all that with the block domain wall and the magnetic field and all that sort of stuff. So if you take this redshift situation and turn it sideways and look at it through the symmetry of the magnet this way through the block wall, you could interpret all the effects they're seeing inherently through the magnetic field. That would explain everything. And then here we're going to play a video from Shane, who illustrates this magnetic field situation, if I remember correctly. And if I don't, that sucks. But we're going to watch it anyway.
I'm going to do a quick little recording on this magnetic field map, right? So it's supposedly the magnetic fields that covered magnetic declination.
Oh man, this is old.
Especially those of us
There was uproar
Yeah.
who are
afterwards.
familiar with the Black Sun model and what
Yeah.
we think the Northern Lights.
Yeah, this is
really
a hot
are. But
minute ago.
anyway, you have this this giant model coming.
So this is a model of our magnetic field vortex and all that. So, that's going on and, could produce all the effects that they see and stuff like that. So when they're talking, so later when we get to the Heffel and Keating experiment where they took flights around the equator going east and west respectively, 2 separate flights, and their devices go out of sync, and we now know that there's an interaction with the magnetic field and all that, we can, you can kind of start to see that there's other possible explanations than time contracted and space contracting proportionally to meet C. So anyway, so I think that was the overall key point of the video, is just to get to show the overlay from bobwins.com. All right. Okay, so the conclusion of the Pound Snyder was inconclusive. Didn't provide any actual evidence for the theory, and there's other explanations for it. So, like, they were suggesting that maybe an experiment should be done with clocks so that they could reference that, because a lot of Einstein's theory is built on clock synchronization and what happens to that synchronization due to acceleration and or gravitational potentials. So we have here the yellow is the before and after, the red is the difference, and the blue is the mean. So for their before and after times, basically what happened, to summarize here, is they had predictions for how much their clock should go out of sync, and all the clocks came out of sync wildly disproportionate to how much that they predicted. So it kind of renders their ability to give viable readings out of it. Based on their predictions, kind of renders it a little useless. So let's see here. So just to summarize here, what happened was the original published data that they published in 1971 or 1970 didn't match the relativistic predictions at all. And then they later republished their work in 1972 with a post-analysis and consolidation of the different factors and corrections for different things that they would have to account for their experiment, and they brought it in alignment with relativistic predictions after that. And they didn't include what they corrected or anything like that. This excerpt here was taken from a paper where a guy kind of reverse engineered based on what he thought they might have had to correct for. So, like, the fact that they didn't publish what they did or corrected for is kind of sus. And then also you can just reverse engineer any, like this guy just worked it out himself to match the same predictions that they got, and so it's just they just mathematically reconsolidated the data to fit relativistic predictions. All they really proved is that moving clocks move out of sync faster than stationary clocks. And to get into what I mean by clocks and atomic clocks and all that, so an atomic clock, when they talk about a cesium atom atomic clock, all that, right? The cesium has a known decay rate for its frequency. So when its energy is decaying, it's vibrating less, basically, right? So it has a known amount of vibration. I think it's 12 billion vibrations a second or something like that. So when it's vibrating at that known amount, it's relatively stable, right? So they can keep it stable. They can by injecting microwave energy into it and having it between two magnetic fields. So earlier when I was talking about electromagnetic retardation, they can kind of use that electromagnetic retardation to balance out anything that's not in that 12 billion oscillation cycle. And then so they'll only get an accurate reading from what's in that magnetic field and what's actually oscillating at that 12 billion predicted cycle rate. So they manufacture the synchronization of the clock in the lab frame. So when the clock is stationary and it's not moving, it's still it goes out of sync. It just slower, right? So when it's in motion, it goes out of sync to varying degrees. And that's all they really proved with that experiment. When you get into the specifics of how the atomic clock works, because a lot of people seem to think that that the cesium atom or whatever that may be, that resonant energy that's vibrating at 12 billion oscillations a second, that just does that in perpetuity or something. But it decays, it goes out of sync, in a stationary situation as well. So they have to constantly provide corrections and utilize two magnetic fields to keep everything, going at that 12 billion oscillation rate. And these are the biggest proofs of relativity, guys. Like this is what they hung their hat on, these interpretations of these experiments as solid evidence. So we're gonna get into gravitational waves real quick. But before we continue, though, does anyone have any questions or anything like that?
I think you should have been a little more sarcastic when you said solid evidence.
Yeah. Okay, so for the fourth proof, gravitational wave. So so it was 1916, Einstein published a paper predicting gravitational waves, saying that there would be, this ripple in space-time due to, XYZ and all that from the gravitational fields, and that this would be something that is measurable and predictable, right? So insert the LIGO lab. So they devised a giant laser interferometer to detect these gravitational waves. Now, sadly, they could not detect Earth's orbital velocity with an interferometer setup, but they can detect something way smaller than that. And so they built this laboratory here. So this is LIGO. So this is a combination of two observation bases, one in Louisiana and one in Washington, I think. Can't remember. It doesn't really matter. But anyway, the idea here is that a gravitational wave will ripple through, space-time, and it will ripple at one lab, and then it'll ripple at the next lab, and they'll be able to get like, a confirmation that, based on the two observations and propagation time, etc., that it's a gravitational wave or whatever, right? So that's how they're gonna isolate it or whatever. So this is an excerpt from the first announcement in 2015, I believe it was, or 2016, when they did their press tour of the first confirmation of a gravitational wave titled GW150914. Very sciencey. So here's our boy successfully announcing gravitational waves real quick.
Ladies and gentlemen, we have detected gravitational waves. We did it. Ladies.
All right, so that dude was super pumped about it. Very very excited. And so a little history on LIGO real quick before we get into the gravitational wave itself. We'll look at the credibility of the institution.
My guys, my guys.
Yeah. So the collaboration, lesser known to people that there was a false blind injection where they injected fake data into the system, and they had the scientists there analyze the data thinking that it was a real test. So by a blind injection, it's what they did is they had a team had private access to their servers and stuff, so they snuck in and implemented a system where they could inject a false positive detection, and then the actual scientists, not knowing that it was a false positive, would analyze this detection and see if it was see if they could distinguish between basically find out if it was fake or not. Basically it was a control test to see if they could discern whether or not it was fake. And so I'll read here from LIGO on their take on the situation on that little blind injection stress test. So the collaboration knew that the detection could be a blind injection, a fake signal added to the data without telling the analyst to test the detector and the analyst and their analysis methods. Nonetheless, the collaboration proceeded under the assumption that the signal was real and wrote and approved a scientific paper reporting the groundbreaking discovery. A few moments later, according to plan, it was revealed that the signal was a blind injection. While the scientists were disappointed that the discovery was not real, the success of the analysis was a compelling demonstration of the collaboration's readiness to detect a gravitational wave. So their readiness to detect anything doesn't mean anything at all, and that's a really positive spin on the fact that they have no actual phenomenon to compare a so-called gravitational wave to, and that they could be successfully fooled by a data simulation. So any thoughts on that, Shane?
Progressively fooled by a data simulation? Not impossible.
Couldn't happen to
I
these
mean,
guys. They're scientists, for God's sake.
Yeah, I think that's fine. I mean, I figured they're trying to test them, like, also to even see if they even notice at all. You know what I mean? Like, not notice is it real or fake, but just, hey, are you asleep on the watch? Did you even notice the thing that you're looking for happened?
Well, no, like
I mean, they're testing them in all ways, right? They
That's
test them in.
that's automated. Well, no, that's automated. They wouldn't need they wouldn't need a guy to like watch it.
Okay,
Anyway.
okay.
when you played the
you're
clip, they were celebrated like they just landed on Mars and like the rover just fell through the atmosphere. They were like, "Yeah,
It was
great."
very,
That's not very believable.
It seemed very practiced, and it also reminiscent of I'm not sure which astronaut it was, but he said that the moon landing simulation would be just as real, and they wouldn't be able to tell the difference.
Right.
Yeah.
But like, so they had that announcement with that crazy emotion, with people going, "Yeah," and then later they were like, "Actually, what happened was we faked some data, and we wanted to make sure it worked. Congratulations, everyone reacted greatly, but someday we'll find the real one soon, right?" Like, didn't something like that happen? Isn't that like, wasn't it that outrageous?
That's why they built it up, because they were so used to fucking rehearsing it. But yeah, I don't know, man. If the blind injection thing, the blind injection was supposed to throw them, like, was it supposed to be outside of, the threshold of what they're looking for? Like, why wouldn't they be fooled by it? Is what I'm saying. Of course they're fucking fooled by it.
Exactly.
Right?
But people seem to think that they're not, and that that there's like a gravitational wave that they could maybe compare it to or something like that. But this just kind of illustrates that it's all theoretical and nobody knows, and you could fool them with a simulation very easily, as it was done. Like, they were ready to publish this and go to bat for it, and then like they had to pull the plug on it because it wasn't real or whatever. And then they had to get the real detection, right? So
I have a funny story about the LIGO in Livingston. I live near it. I called them up several times, and the first time I called them, I said, "Is it true that the LIGO laser is horizontal?" Like, I just mentioned the word horizontal, and his reaction and his answer to me was, "You can go to the beach and see boats go over a curve. Now you can't make that stuff up. Like that was his answer. The engineer in the office, that's what he told me.
Seems like he's gotten a few phone calls before you, maybe.
yeah. I gave no inclination that I had anything to do with flat Earth or whatever. I was just asking about the tube, the vacuum tube, and the laser being horizontal. And he mentioned going to the beach and watching boats go over.
Imagine showing him this presentation, huh?
How did you react to that? Did you tell him that actually the boats over the curve don't prove a ball? Did you even get into the conversation at all, or?
No, I didn't even like go into what he was talking about. I said, yeah, I go to the beach all the time. I'm not even asking that. I'm talking about LIGO. What you're over, and he just wouldn't go into it. But I've called twice and talked to 2 other people, and they were supposed to have like start opening. They call it Science Saturday or something like that. But they had shut it down due to the epidemic. But they haven't opened it back up, and then they were doing construction on a 3rd tube there, another tube that goes in.
Hey, sorry to cut you off. Like, well, I'm gonna continue the presentation. Sorry, we'll pick up on the LIGO afterwards. All right. Okay, so to wrap up here on LIGO, so the successful confirmation of GW150914, they said that this confirmation was done before the system was fully operational after a reboot had been done to the service after maintenance. So it was done after maintenance, and the safeguards where they have a system that prevents false positives. That system wasn't running either, so they weren't. Even under those conditions, they were still like, "No, we got to take this, boys. This is our golden goose." So they went ahead and went with that as their big publication for their gravitational waves. And every year, I think they make like one detection or something, or they'll publish something and act like they're doing something. But a real quick thing on black holes. So black holes are derived from an event called a singularity, and to describe a singularity, that's a mathematical concept of tending towards the difference between like 1 and 0 would be infinity if 1 could always tend to 0, right? Like 0.1, 0, or 0.01, 0.02, that kind of thing. So it goes to infinity. It's the concept, right? It's not real. At some point, you're going to physically hit that limit, and there's not going to be an infinite tendency towards 0, right? So this is a mathematical concept. So through the Schwarzschild metric and descriptions and all that, they impose conditions on the metrics. When they break the metric, it imposes what's called a singularity, where the space-time curvature folds in on itself infinitely, and it just breaks down all their math, right? And it produces all this crazy stuff where that's where they get like this gravitational potential of a star collapsing, and it creates a black hole. It sucks everything into it, and once you get within the event horizon, not even light can escape, and all that. So all that comes from a mathematical concept where they have imposed conditions on a metric and then broke the metric, and then turned the breaking of the metric into like a pop culture reference, and made a bunch of movies about it. And I'll be honest with you, like, I love black holes. That was like one of my favorite parts of being a heliocentrist, is that there's black holes in the sky and gravitational getting lost in a black hole and stuff like that was always the coolest concept ever, right? Like what goes on in a black hole, like all that kind of stuff. It's all just based on them imposing conditions on a metric that the metric can't define, and then out of that they tell a story about it, and then they use this gravitational wave prediction to help reify that. And then so in a mathematical analysis by a man named Stephen Crothers, he shows that how they derive the gravitational wave solution. It's actually meaningless, because if you transform that gravitational wave into another coordinate system where the medium doesn't have the permittivity and permeability of a vacuum, the speed changes, so it doesn't provide invariant transformations. So it's non-covariant. It means nothing. It's not a law of physics. It's not predicted by anything. The fact that it propagates at the speed of light is only done because it was chosen in a respective coordinate system to like facilitate the illusion that it supports the Einsteinian mathematics and all that. And that was from Stephen Crothers, and there's a link to that I can provide. But that was his analysis of that, and he does a transformation of it and shows the speed propagation changes. So like this whole concept of it matching a gravitational wave and all that is just, it's not real at all. It was just chosen to give for them to have the ability to calculate it, right? So really, really unfortunate. All right. So we'll move on now from the gravitational wave detections. Let's see here. What do we got? Okay, so experiments with light. So this is getting into the special relativity side of things. So this was the jumping off point before the general theory and how they hinged them together. I'm sorry, with the equivalence principle and all that. So, but both theories, general and special, are both based on the constancy of the speed of light. So we're going to analyze some experiments with the speed of light and see how those turned out. So with Michelson-Morley, the speed of light varied, and to explain that, they said that there was length contraction within the coordinate system, and because the reading that they got from Michelson-Morley didn't correspond to 30 kilometers a second. So with that, they were unable to successfully confirm heliocentrism. So to say that the speed of light was truly the same, they had to, and that the Earth was truly in motion. Using relativity theory, they were able to say that the apparatus could contracted in the direction of motion, and that produced that variance in the speed of light, which if you reverse engineer the contraction would produce the full 30 kilometer reading, right? So that was their jumping off point for that. And Louis Essen has a little quote here of relativity theory, and he says, the contraction of length and time dilation can now be understood as representing the changes that have been made to make the results of measurement consistent. There is no question here of a physical theory, but simply of a new system of units which c is a constant, and length and time do not have constant units, but have units that vary with with v squared and over c squared. Thus, they are no longer independent, and space and time are intermixed by definition, and not as a result of some peculiar property of nature. So Louis Essen, the godfather of the atomic clock and big proponent of relativity theory until later in his retirement, he realized that there was a bunch of inconsistencies with the theory, and that it wasn't logically sound or tenable to as a framework. So he went against it. So this was a quote that he had, describing what was going on. Basically, to turn C into a ruler stick, space and time have to contract proportionally. So that's where you get into the length contraction and time dilation. Those are that's what that means. All right, and thanks Witsit. So what were we thanking Witsit for? It's been a while since I've done this, so I don't remember some of it. Sorry. So if David Miller results, a little, did I talk about Miller? Let's see. Oh, okay, yeah. So with the history of interferometry, real quick, Michelson-Morley was redone by Dayton Miller from 1905 to 1925, where he did 5,200,000 measurements with interferometry, where he consistently measured a variance to the speed of light. He actually accurately mapped out the what he thought was just albeit at a lower speed, at a lower translational speed, but he thought that he was measuring the elliptical orbit of the sun or of the Earth around the sun. So as we see the analemma, mapped over the course of a year, where that discrepancy of the north and the south, they say in the Earth's orbital or Earth's elliptical orbit, when to complete that, the Earth has to speed up and slow down 4 times a year or 2 times a year, 4 times respectively, to facilitate that motion. And when it's further away, that's when you're getting that bigger arc for the analemma and all that. So he thought that that's what he was measuring, with interferometry. He measured it so accurately down to the day where the interferometer was getting its minimum and maximum dimensions on the fringe readings on the day to the equinoxes. So he was consistently measuring that, but that was through an ether framework of interpretation. So nobody was interested in Miller's readings in his continued showing of the variance of the speed of light. So they chalk Miller up to they say that he didn't know about temperature differentials in his work, and that there's some statistical analysis error with his work. And to not get fully sidebarred on all that, there's more repeated effects with interferometry with Sagnac, Michelson, Gale, Ruyang Wang, DeFore and Pruner, lots of other people showing a variance to the speed of light, but we'll get into those in a bit. So here we have Einstein saying, if Dr. Miller's results should be confirmed, then the special relativity theory, and with it the general theory in its present form falls. Experiment is the supreme judge. Only the equivalence of inertia and weight which remain or would remain, which lead to an essentially different theory. Albert Einstein, Science Magazine, 1925. So that was his thoughts on Miller's work. So he was well aware of Miller and all that. They just kind of downplay it, and they ended up just not talking about until he died. So so anyway, to explain the variance in the speed of light, the special relativity framework is proposed, where they use what's called Lorentz transformations, where they go to a different reference frame to observe a non-variance in the speed of light and explain the variance in the speed of light in the current reference frame through a mechanism of length contraction and time dilation, where the amounts of length contracted and dilated are verified in the new reference frame. So that's what they came up with to get into that, and to show the SAGNEC device. So I'm not going to get into interferometry too much because it's already a long presentation, and that's kind of a separate thing. But the Michelson-Morley setup was, 90 degrees, perpendicular to one another on an axis situation. So with the SAGNEC, it was a circular rotating device. The path of the light beam was circular in that regard. So they considered that apparatus different, and because it's rotating, they say it's a non-inertial reference frame and all that. So they let it slide. But then through general relativity and the equivalence principle, they co-opt the SAGNEC effect, saying that the rotation of the device, the energy of that, is equivalent to generating little pockets of time dilation and length contraction within the device to produce the effects of the French shift. And remember, the special theory is linked to the general theory through the equivalence principle. So the relativists have a quote unquote think they have a successful explanation for the SAGNEC effect through the metric tensor provided by Paul Lavue to describe the angular momentum on the small scale of a tiny rotating device. All right. So some demonstrations of that. So in 2003, Ruyang Wang did an experiment with a linear fiber optic cable wrapped around a conveyor, or he basically made a conveyor belt out of a fiber optic cable. And what he found was that the circular bits also that the linear bits contribute to the French shift pattern, as well as the predicted the assumed circular bits would contribute to the effect. So it basically took away the relativistic explanation of the effect, because what Wang showed is that it's not an effect due to rotation or anything like that. It's a directionally dependent effect, meaning that the effect persists when the device was aligned east to west and west to east, and the propagation would go faster going east to west and slower going east to west at the same rate. Let's see, Ives Stillwell. So Ives Stillwell was where they came up with the transverse Doppler effect. So the relative motion redshift situation that I was talking about earlier at the beginning of the slide. So basically what they had was a big conveyor belt, a device mounted on it that was going to shoot a beam, and then they were looking for redshift based on the relative motion of that. They found it, and then they attribute it to relativistic effects. However, the effects shown can't be distinguished from, the effects are indistinguishable from classic mechanics effects. So like with an ether effect where you're having relative motion Doppler shift, the effects produced are within that same measurement error. There was a paper by Daniel Gezery who points that out, and to close on what he ends on. So he says, furthermore, it is a little known fact that the classical transverse Doppler effect that is observed in acoustics, which suggest an analog in the classical wave theory, so a medium for light, although no such effect is described in the textbook. So in modern textbooks, they don't tell you that all these effects, that all these so-called relativistic effects and whatnot, are explainable with classical wave mechanics, with a medium and all that. So here's a list of modern interferometer experiments: Silvertooth, Kennedy Thorndike, et cetera, et cetera. So what you'll find is that the interferometers now are tending towards zero, and this is facilitated by the way that the experiments are done to explicitly give a reading that matches the relativistic prediction. And they do this by changing the location of the sensor in the apparatus. They change the medium of the medium of the tubes or whatever that the light is propagating in. They'll either add a gas or change the type of gas or do it in a vacuum. They'll do some variation of it, or they'll what's the other thing they do? Can't remember off the top of my head. But they change the length of the arms of the apparatus, make them out of proportion, stuff like that. And so changing those factors will give you varying readings. And when they do them in a basement as well, it also affects the reading. So they go well below sea level, and then they go in a basement, in a concrete basement, in a steel building to do the readings, and they get the effects still persist. Like they still get a small reading, but it's just way lower, and they attribute that to tending towards zero, and they say that that's successful positive confirmation of the invariance of C and supports relativity theory and all that. So. And all of that was already discovered and figured out by Dayton Miller between 1905 and 1925 through his work with interferometry. So all the effects that they use now to basically hijack interferometry and make it seem like it supports relativity theory, all the groundwork was done by Dayton Miller over the course of about 30 years. So that was cool. So here we have the photon for vacuum propagation. So we have, what is the photon? So we have three equations here that describe the photon and the frequency of the photon, and its behavior and its momentum, and how they facilitate vacuum propagation of the photon. So we have the classical way to derive momentum. So P equals m times v. So momentum is described by P times v. So mass times velocity gives you your momentum. So that was the classic understanding of it. And the way that they ended up describing the momentum, the physicality of the photon, so to speak, through this equation, they have P equals delta equals HKV, which is the reduced Planck's constant times K. So here, P is the momentum of the photon, delta is the wavelength, K is the wave vector, H is the Planck's constant, and H with the funny letter is the reduced Planck's constant. So what they do to scale the energy proportional to make the physicality of the photon zero as the energy scales is this reduced Planck's constant basically scales all the energy proportionally to zero, so that it actually has no physicality, but it still has the ability to have momentum, right? So that's how they mathematically facilitate that. So, but the use of Planck's constant and all that, which we'll get into here in a second with hertz and frequencies and whatnot. So all these are wave equations. The physicality of the photon that is required of it to propagate through a vacuum only exists in our imaginations. If the conceptual mathematic extrapolation of the physicality and behavior of the photon existed as described by the wave equations, the length of the photon would be directly proportional to the length of its wavelength of the wavelength's existence. So the speed of light is set by c. So that's 2,900,792,458 meters per second, and this means that a photon that exists at a frequency of 3 hertz for 1 second would be 300 million meters long conceptually. So, like, if they were trying to attribute the physicality, to it, because a lot of people seem to think that there's an experiment that proves that there's a wave particle duality and that sort of stuff. So, similarly to how there's no instant action at a distance, but there's no time variable in Newton's equations to account for the propagation of gravity. There in Planck's equations, there's no time variable either. So by default, it's set to 1 second because Planck's constant his solution was derived from a data set. That curve from the black body radiation is from a data set that's 1 second long. So everything defaults to that. So so if you're a wave particle duality person, the physicality of the photon that you believe in would by default have to be proportional to the existence of the wavelength, right? So if it propagated for 1 second, it would be 300 million meters long because the speed of light is 300 million meters per second.
We got to
Let's
come back to
see.
that.
Absolutely. So there we have that.
That's true.
All right. So, and then we're going to get into a little mathematical analysis of relativity theory. And a lot of this analysis was by Stephen Crothers. And I'm just going to break down some of the terminology here to familiarize us with the lingo here. So we have examples of tensors. So the Einstein tensor. So we got your GUV, your Ricci tensor, your RUV, your pseudo tensor, your TUV, and all that. So when we're talking about the different types of tensors and the equations, that's what they're represented by. So the words covariant, when you hear covariant, this is used to describe a tensor that under transformation is in accordance with the rules of covariant transformations, meaning that the geometric properties, when transferred to a new coordinate system, are independent of the new coordinate system, meaning that they don't change. So when the speed of light is transformed to another coordinate system, so it's represented by c, right? So that speed, when it's transformed to a new coordinate system, it has to be the same. So there's laws for conservation laws and stuff like that are represented mathematically. So the pseudo tensor here is for the conservation laws. So things like this have to produce invariant transformations to be covariant, and covariance is supposed to establish a meaningful relationship with the mathematics, with the abstract mathematics, and in reality, right? So if your theory is mathematically covariant, it's a good indication that you're not just making things up to cook the book, so to speak, right? So it's like that's how you would indicate that, because we've all kind of heard um, about reference frames and how things are how the speeds of things are the same in all reference frames, and how this was validated by this reference frame and that reference frame, and it's like, who went to the reference frame to validate it? Well, they do it mathematically under transformations with these laws of physics, and when they transform them to the new reference frame, as long as the coordinate system has contracted and time is dilated proportionally, they can get their calculations out of it, and it gives the appearance of covariance. Now, the thing with the way that Einstein, with the evolution of the mathematics for Einstein's theory, he ended on absolute differential calculus, where you could use these metric tensors and indices to describe coordinate systems within them and all that. When he switched to that differential calculus, the thing with that is if you change the initial conditions or the boundary conditions, you can kind of facilitate whatever you need to get the result you need to. So the relevance of covariance in that regard, even though it was already spotty before with just sticking to the algebraic transformations, but towards the the final evolution of the theory in its current form allows for it's already built into it to have you can just swap out a different tensor to get the effects that you need. Basically, is what's going on there. And then so to get into the analyzation of the tensors themselves is how we're going to analyze the validity of the calculations that they're producing, right? Because they are calculating, right? But is it real? Is it meaningful? Well, we're going to learn some terminology here and figure out if it is or not. So invariant means that a quantity that remains unchanged under a given transformation. Example, c, the speed of light. So like I was talking about earlier, if your mathematic theory is covariant, then when you transform the laws of physics, those transformations will be invariant. Okay. So a transformation is a mathematical operation that maps a set of objects to another set of objects while preserving a certain set of properties of the original system. So this is just transforming from one coordinate system to another coordinate system, and then your new coordinate system is going to have corrections built in from the old coordinate system. So your new XYZ variables will be, your X variable might be X minus, some other variable or number that that's relative to the new coordinate system that you're transforming into. So a tensor is a mathematical object that represents a linear relationship between sets of vectors, scalars, and other tensors. A pseudotensor is a tensor-like object that transforms like a tensor under transformations, but not others. So it allows um, for you to transform to certain coordinate systems and like give the illusion of covariance, right? It'll make it look like that this is a covariant transformation, but if you transform that law of physics or whatever you're doing to a different coordinate system, it's actually going to break and and not be a covariant transformation. So this is so you can bring in the pseudo tensor to transform or to allow for that covariant relationship, right? So like I was talking about earlier, how you can change the boundary conditions. So you just swap in the your conservation tensor here, your pseudo tensor, and then you can extrapolate the effects you need to relative to your initial input condition for your space-time curvature. That sounds like a lot, but it's gonna hopefully make sense, but who knows.
Are you going to be able to draw this for us?
Draw? What do you mean? Like show some like do the math out and show you?
Yeah, we gotta. Yeah, because you're awesome with the slides and stuff like this. So I think what would be great would to be like compile a fucking transforming object, like little diagrams and figures of the photon, like as you on all together, like on one whiteboard, like keep adding, and then kind of have a summary shot of all of it from beginning to end. You know what I mean? That'd be kind of cool.
Yeah, that would be a good way to visually represent it. And if you would like to see someone actually do the math and extract it out, because what we're going to go over here in a second is this process of contraction. There's a video on that Sky Scholar channel that I mentioned earlier by a guy named Stephen Crothers. I can link the video. He actually goes through the process of this analysis that I'm breaking down all the terminology of and shows this first order intrinsic differential problem. It's really interesting to watch, but it's kind of dry.
Here we go again. It's just so many terms and like logical attacks, and it, you know what I mean. And it's just to go back and, you know what I mean, like each point of logical attack, like you know what I mean. It's wait, was this one in agreement? Was this one in disagreement? You know what I'm saying? Like you just have it all kind of summarized.
Yeah, they built. It's really confusing, and there's a lot of discrepancies and hiding and the appearance of mathematics where they use these like literal mathematical logic fallacies to build the appearance of being able to like give these calculations. But what we're going to find out here is that these are physically meaningless calculations relative to the mechanisms in which they're trying to attribute the phenomenon to, i.e., the bending and warping of space and time. So a first order intrinsic invariant differential. So this is a type of invariant tensor that is coordinate dependent and changes under transformation. It is composed solely of the components of a tensor and its first derivatives. It is not derived from the field equations themselves and cannot obtain a second order field and cannot be obtained from second order field equations, which violates the mathematical structure of the theory based on the principles of covariance, and that the idea that the physical laws should be independent of the choice of the coordinate system. So in reference to into what that means basically is, so the first two postulates of special relativity are that all inertial reference frames are equally valid and that there's no preferred frame. So so mathematically speaking,
And that's so we could throw that motherfucker out because we all know that's some bullshit.
Yeah. So mathematically speaking, they they can try and like you facilitate the truthfulness of that mathematically, right? And then the second postulate is that the speed of light is the same for all observers and is independent of the source or of the motion of the source or observer. So with that being said, they have let's see. With that being said, they have a mathematical framework in which they can interpret experimental results and all that stuff, right? So they need God, that kind of threw me off. Let's see. Cannot describe themselves. Framework which violates the theory, the principle. Okay, yeah. So to facilitate like things like the conservation laws and whatnot, right? Like your boy Paul Lavue that came through in 1913 to explain length contraction and time dilation through a rotating device through a pseudo tensor specially derived, the Landau-Lifshitz Fitzgerald metric or something like that. I think it's called. So to derive something like that, what they did is they derived it from this GUV instead of being from the original field equations. And that violation, and like, so what they did is like they packed in a way uh to like make it mathematically look like, they have a way to give a covariant transformation to everything, but they just kind of made that mechanism where, like I was saying earlier, how you can just swap in a tensor and swap it out. So contraction is a mathematical operation that involves summing all the components of a tensor in a specific way to extract information about the state of the tensor it's describing. So to think about that for a second, so if you think about the Einstein tensor here, this GUV, if you think about that, like I gave you instructions to bake a vanilla cake, and I said, here's all the ingredients you need, and here's how you're going to make this 4-layer vanilla cake, and you're like, okay, cool, and you didn't have one of the ingredients, right? So you were like, okay, I'm just going to derive the ingredients from the ingredients that I do have, instead of getting it from the list or whatever, like getting it from its own respective thing, right? You're just going to combine some stuff, and you make your 4-layer vanilla cake, and you present it to me, and I look at it, and I'm like, wow, that looks like a vanilla cake. You did it. And then I'm like, okay, well, let's verify that it's a vanilla cake though. So we verify that by compressing all 4 layers of that cake down into one layer. And when I compress that layer, it's not a vanilla cake anymore. It's actually a chocolate cake. And that's the, if that kind of gives an analogous way to describe what's going on with the transformations and the validity of the mathematics, where on the calculation it appears like they calculated something, but when you actually contract these tensors and do an analysis of the results that they derive, you find that due to the first order intrinsic invariant differential violation of the structure, it leads to physically meaningless results. Okay, and then so conservation of energy and momentum. So these are the physical principles that state the total energy and momentum in a closed system are conserved over time. And in relativity theory, gravitational fields in space-time curvature tends to infinity, which violates the conservation laws. So they had to have, that's why deriving this was so important, because if you couldn't describe the conservation laws, nobody was going to take relativity theory seriously. So they were forced to a position where sorry for a second, they had to use this pseudo tensor to facilitate the appearance of mathematics. And when you really break it down and do a dimensional analysis of it through contraction, it's all a reification fallacy. And this was all pointed out by the 2 gentlemen that invented differential calculus. Forget their names. It's cited here on the next page, I think. I'll read it off when I get to it. But yeah, like this whole structure and everything, like this is all known about, and other people have pointed it out besides Crothers. But I like to point out his work because he actually has a video of him going over the mathematics and solving it, so you can see in real time what it looks like to contract it out and see the violation and the meaninglessness of it. And he doesn't define the terminology like I do here, so this will kind of give you some reference if you want to go check that out later, and then you can actually understand a little bit what he's talking about, because he just kind of assumes everyone already knows what these words mean when he does it. And no one knows what a fucking first order intrinsic invariant differential is, so let's be real. So a second order differential equation is a mathematical equation that involves a function, its derivatives and its second derivatives. Einstein's field equations are second order differential equations that describe the relationship between spacetime curvature and the distribution of matter and energy within it. The curvature of spacetime is affected by the presence of matter and energy within it, right? And so to just give you some reference on what those equations look like again, so there's your TUV, So they have the upper Odysee in this iteration of it, but they later use all sub ones. So, um, so yeah, this violation was pointed out by a what is it? Sometime in the 1920s. I don't have the exact date, but it was pointed out by a Russian guy named Luganov and uh, Metsa, you know, that guy. So anyway, those two gentlemen pointed out this as well from back then. So this is like a well-known thing that just isn't really talked about. Let's see. Oh yeah, so Ricky Cabastro and Levi Savita, those are the two gentlemen that invented differential calculus and basically the framework that Einstein used and all that. And then so the metric that so all the metrics for the conservation laws that are used to calculate these, to make these calculations and stuff are all first order intrinsic and invariant differential, logical fallacies, basically, right? So like it's physically meaningless in the equations. Let's see. So to close on it, it's all so to end on that mathematical analysis recap. So the tensor calculus used to describe an I-beam and the stress relationship between 2 points in it and all that, like, very meaningful because you have to use real numbers, you have to use real values, real amounts, the real weight of something, right? You can't just make something up or bend a coordinate system to contract it to what you need it to fit something that you need as your measuring stick, right? So I'll read here from the conclusion and then we're pretty much done, boys, and I'll open the floor to further discussion. So, how math became reality conclusion. In conclusion, the historical and classical experimental evidence put forward as proof of the theory of relativity does not support it and the theory has entirely collapsed in on itself at free fall speeds, revealing it to be a mathematical prank played on us all. In my opinion, there was a deliberate effort to promote the theory of relativity and make it widely accepted. Someone or some group of individuals realized that they could use this framework of space-time curvature interpretation to manipulate the concept of time in natural electromagnetic phenomenon. This was done by using the space-time metaphors supported by abstract mathematics. The term space-time or space-time curvature is misleading and imaginary. There is no experimental proof of the theory of relativity theory. There is no experimental proof that the theory of relativity is anything beyond a mathematical framework. Space-time poses no physical attributes and cannot distort or alter a path of mass or massless objects moving along any non-existent curvature. Some individuals think that relativity theory has been verified because its predictions have been validated on several occasions. However, other concepts like Lorentz's ether theory also produce comparable outcomes. This issue with relativity theory, or the issue with relativity theory, is that it employs mathematics to predict successfully, but the way that it describes time and space is illogical and even goes against established knowledge. The underlying problem arises from the switch from Lorentz's concept of absolute time and a variable speed of light to Einstein's relative time and a constant speed of light. The Sagnac effect demonstrates the speed of light can vary based on an observer's position, which can make time appear to pass differently. The major differences between the two systems is that Lorentz system implies the stars, planets, and galaxies and other celestial objects are closer to us and exist in a denser medium. In contrast, the relativity theory is essentially an inverse of the ether theory, inverse of a ether theory of a closer and denser medium, which allows for a broader range of interpretation concerning the distances and sizes and the nature of the phenomenon in a vacuum. 1 second. Had to get some water. My throat was getting dry there. Okay, let's see. So so broader interpretation for the sizes and distances for the objects that we see in the sky. The reason why mainstream science can state with a straight face that a photon has traveled 7 or 13.7 billion years to reach our eyes and has covered a distance of 80 sextillion 600 who knows, quadrillion billion million miles is due to the inversion of that constant speed of time, or that constant speed of light in relative time. Experiments should progress the validation of theories rather than theories influencing the experiments, so that data can selectively be used to confirm the theory. All right. So I got a MediaFire link for all the sources from that presentation, if anyone's interested in them. And I think that was it. Cool.
Nice.
That's it.
You chopped that down to 2 hours and 4 minutes, dude. Holy crap.
Not bad, dude. The speed run, bro. Speed run. Oh. So is there any questions or comments or anything? I'll unmute that guy.
All the Globers left.
There you go. All good. Sorry about that. EEEERA. I just wanted to get through that last bit there. I was almost done and wanted to close out on some high momentum there.
Dude, I love that part about the gravitational waves being detected, and they're like, yeah, and they're like, yeah, we did it. Yeah, we did it. And then, like, actually, okay, so what happened was we made it up, but it was like for really good reasons, and it was to help you. And they were like, yeah, that's okay, guys. And then later, like 2 weeks later, they were like, yeah, so we did it for real this time. People were like, yeah, and then that was it. That was the whole gravitational wave detection process as it unfolded in real time.
Yep.
Fucking nonsense.
Yep. And every couple of years, they release a paper saying that they made another detection. And similarly, those detections are made under similar circumstances, where that first one was made where their system wasn't fully operational after maintenance, and their safeguard for preventing false positives was down. So it's like that's openly part of the first successful confirmation detection, where it's like, what was that, bud? You said you detected it while it wasn't fully operational and while it had no false positive way to eliminate that. What are you talking about there, bud?
That's one of those things you can look at the historicity of it and remove all the science and the math and the equations and the elevated concepts that maybe you don't understand, and just look at it and look at what happened and go, oh, yeah, no.
And just go, nah.
Yeah, honestly.
Like, nah, I don't have to agree to that. Nah.
Like when you figure out that like NASA was founded the year after they explored Antarctica, and went, what? Wait a second. Everyone don't look out. Look up. Look, we're going to the moon. You know?
Yep. Yeah, so did the audio improve after I switched to a lower bit rate?
Yeah, well, the audio was fine. It was the cam kept buffering, like it was stuttering and freezing, and like we heard the audio in your normal Discord quality, but
it was just the cam itself. Oh,
yeah,
shit. Okay.
Yeah, that's all right. It was fine.
That's okay. Yeah, I wanted to do the whole thing on cam, but that's all good.
You turned it off immediately, and I was like, well, I guess that is better. But I meant like
what?
But
I don't
you were
have
doing a virtual cam, so yeah, I didn't know.
Yeah. The way I have my OBS set up, it wouldn't. Anyway, we can talk about that later. But yeah, is there any questions, comments, concerns? Anyone ever have a relativity question? You were like, oh, I wonder what happens if or what the explanation is. Hit me up.
Atomic clocks, cesium atoms, all the crazy oscillations. How about the fact that it's the most provable, repeatable Michelson-Morley non-ether null experiment that they can keep repeating, except that they got to keep changing the parameters in the arms and put it in the basement, and to get different results, it's like do it a little bit crooked. I mean, no, does anyone want to bring that up?
Yeah. Yeah, that's one of my favorite ones, because like Einstein was saying, David Miller just absolutely obliterated the theory with his measurements, and then his work has been reproduced since then by two different people. and then the effect obviously showing to persist without rotational effects. So like they eliminated their one mechanism for even explaining it through the way that they had to mathematically co-opt it through a mathematical reification fallacy to inform their coordinate system, proportionally.
Oh, hold on. I have a tensor for that. Don't worry about it, bud.
Yeah, hold on. There's a tensor for that, bud. Yeah. Yeah, man. Awesome, dude.
Excellent work, dude. Thanks again for bringing this awesome work to the forefront so that we can be properly armed with the knowledge that our forefathers already possess.
Yeah, man. The motivation for this presentation was I would watch Witsit debate people on relativity theory, and he would just like, just dunk on it, obviously. And then they would be like, nah, it was proven. And then they would just like cite Wikipedia and be like, Pound
Right.
Repka explains this. So I was like, okay, well, let's see. And then I read the paper and it was like, well, turns out we don't really support relativity theory and we actually can't make any positive claims on it. Maybe somebody will figure it out at a later date. And I was like, oh, really? So I was like, okay, well, let's just go through all of the big ones. So yeah, this whole list that I went through was basically, if you go to Wikipedia and type proof of relativity theory, you'll get everything on this presentation pretty much to
Nice.
the T.
Which is
And
so
then, yeah,
astounding.
So yeah, you have well-equipped information on how to describe everything and all the relativistic effects and all that.
And once you have the totality of the knowledge, you got to be like, how fucking dare they? They took everything that refuted their model and like proposed our model, perpetuated ether theory, an energetic background, confirmed stationary, non-moving in every reference frame, confirmed preferred direction only inherent to a flare. And they were like, that's all globe proof. And people were like, fucking flirt, look, that's globe proof. Well, like, and we were like, oh yeah. Nobody looked into it, dude. What the hell?
Yeah. They just browbeat everyone and told them that they weren't smart enough to understand it.
And we bought it and we let them do it.
Yeah. And then we thought we were cool, talking about black holes. Like, I can't tell you how much I used to love black holes, boys. That was my favorite, like, space-time event. Like, I couldn't learn enough about them, Just loved it.
Right?
It was so cool.
Dude, mathematical boogeymen based on sky demons. That's awesome.
Yeah, based on a sky demon predicted by a sky prophet. Yeah, it eats light. Yeah.
Stuff for bedtime stories, man. Well.
Yep. Yeah. So we can go ahead and wrap up the presentation if there's no further questions, comments. I'll go ahead and stop streaming. And then Shane, if you want to roll an outro or end it however you want to end it, let me know and I'll close it out.
Yeah, we can do that.
I'll stick around for a little bit if anyone has like delayed questions or whatever, but I'll be right back. Gonna hit. Yeah, I'll be AFK for a minute. Shane, I'll let you decide how you're gonna end it.
Oh, I'm rolling it now.
All right, cool.
I don't think anyone wants to talk about relativity, to be honest.
I love it.
Is Witsit here? Witsit loves relativity.
Yeah, sort of.
That's like a mostly no. But yeah, man, that was great. Did you say you whipped it out on Globebusters the other day? I missed that one, dude.
Yeah, apparently Zach canceled. Witsit was moving, and I think Iru couldn't make it. So Jaren asked me if I had anything to go on with, and I was like, "Well, I do have this presentation I haven't done in like 4 months."
It's not new, but like it's like it'll be new to you because you didn't remember the last time, right? So
So I did it there the other day. So I had like an hour refresher up until like the Eddington narrative, basically, is where we covered last time. Or we're about what I got to, I think, right around there. So yeah, we'll go ahead and end it out. All right, cool. I ended it. Shane, you're good. Thank you for recording that or uploading it for me. Appreciate it.
Crap, I do have a 2-hour recording. I need to do anything with that, right?
No, you're good. Your conscience is clear, unless you want to put the 5th iteration up on Rumble or whatever.
Nicely done, my brother.
Thank you, man. Thank you. Did you get moved? Are you all settled in, or like, what's up, bro?
I mean, I'm in the other house. Yeah.
Nice.
There's stuff everywhere.
Nice. Congratulations, man.
Thank you, bro. It's cool.
So now you live in the swamp, I guess.
Yeah. Jealousy is not a cute quality, bro.
Is that what it sounded like to you?
Yeah, they don't refer to paradise as a swamp. No. That's what the Floridians call it, I guess. But I have to set up the stream room, and then we should be good to go here soon. Moving sucks, though, in case anyone was wondering.
Yeah, it's not great.
Yeah. Fuck moving.
It's terrible.
My father-in-law just switched houses. He moved from one house to the other. Sold the one he was in, and he didn't hire anything out, and so he spent 60 days. Okay, doing it all himself. The whole house, everything. Of course, I helped him, but like he did most of it. Like, oh man, and he had to drive every time he took a load from the house, from his old house to his new house, he had to drive like 2.5 hours every single time. It's like, oh my god, fuck all of that. But he got it done. And once you're done moving, once you finish, you're like, that was a lot of work, and I'm so glad that I did it. But during it, you're like, fuck this, fuck this, fuck this. Ooh, oh, Murphy. Yeah, of course, my keys would drop into in the middle of that thing there, so I have to put everything down and grab them, and then pick everything back up. And I dropped them again in almost the same spot. God, that kind of thing. Anyway,
yeah. What's crazy about it for us, bro, is like we're just renting this place, so like it's like temporary. And so it's like depressing, low-key.
Yeah, because you're gonna move again. What, in 6 months or what?
Yeah. Well, no, like a couple years.
Oh, okay, that's not that bad. Be alright.
Yeah. Well, yeah, it's cool, man. It's all good. I mean, I did pretty much all of it. We had like a 26-foot U-Haul, and I did pay movers to like help pack it in, like Tetris style. And we got it on there, and I drove it down.
Well played.
So, Alan, just to clarify, after all this research, you do believe in relativity?
Oh, dude, it made me believe in it the most hardest.
Oh, dude, if it's the most hardest, then it's legit.
Yeah, it's like, squared infinity, like in all reference frames. I believe in it.
You believe
from
in it
every
in
reference frame.
Yeah.
Yeah,
man,
like the Eddington, man. I want to like cover some of that on the stream because that's like I did not know all the wizardry involved with the Eddington experiment.
Yeah, man, they had to push that through because those gravitational redshift obs were killing them, dude. And they were like, yeah, this is dog shit. You have no mechanism to describe curvature. Like your orbital mechanics don't make any sense. Like they all saw it. It's like I was saying, the frequency shift predicted by those equations, would be like that was their cause and effect, man. And they just, I don't know if you heard that or if it got censored out, but it was a fart noise because they, shat the bed there. So they got nothing. So they just tell everyone like, repeat the Eddington story as if it's true. And like, that's all they do. But when you look into it, it's, it's not true at all.
Dude, rest assured that despite this mountain of evidence and information that you've compiled refuting it, dude, it will be one of the first things invoked when you like a couple weeks ago some dude jumped in and he was like clearly he's new to this arena, he's like, I'm about to go show these stupid flat earthers up. He brought up relativity being like the most scientifically proven theory ever, and I asked him how. Dude, his go-to was the star bending around the sun, like the Eddington. Nice. I'm like, you're talking about Eddington? He's like, yeah, that's it. Yeah. I'm like, are you reading Wikipedia about
that's so funny, dude. They do too.
It is.
They love
Someone
it.
went down the list and you're like, actually, if you have 2.5 hours, my buddy Alan refutes each and every one of these in order with an alarming degree of specificity if you're interested.
Dude, that's why I did it based off of the Wikipedia format. Like, literally went down all their experimental proofs because that's what they would do in every debate. Witsit would do. They would be like, "Yeah, well, Eddington looked up in the sky and saw the stars moved and gravitational field. Therefore, it's like, okay, dude. Well, like, let's look into it though for real." And then,
what still sucks though? It still sucks about what still sucks is like, say I'm in a debate and it comes up, it's like I don't have the time to. There's so much wizardry, right? So it's like in a debate, it's like, well, this is what actually happened, and I have to find a way to take this and boil it down to like a concise 30-second, like robotic super speed
Yeah.
response, just so it can get dismissed as like word salad.
Yeah, dude, I need to do the same because I'm entering the debate arena as well. I got McToon on October 10th on Jaren's show.
Oh yeah, you should
Oh,
say
man.
that after you present every time. You should be like, oh, when I publicly declare anyone who thinks differently or thinks my accuracy and facts are to be questioned, come tell me about it in a formal debate. And here you go, right?
Oh, dude, you know what? I
Well,
totally should do that. I like the concept of that. When I was reading through Demio's paper on Miller's work, there was an event that Miller and Mickelson and Morley, who were two separate people, by the way, got together at a public event and openly debated anyone on interferometry and the existence of the ether. And I was like, dude, that's so badass. Like those three legends
Right.
just got together one night and was like, you guys want to talk about space time? Meet us here at the podium, boys, and we'll settle it for you.
You
So
know, it's
yeah, like
funny.
yeah. So yeah, I actually really like that approach. Like I want to get into it. So yeah.
Yeah,
I've never heard that.
If you actually challenge Einstein, you got actually accused of being anti-Semitic. Though you couldn't actually debate Einstein. You would never go to the podium for real. If you look into it, you'll find that out.
Of course.
Yeah. The results of that night, didn't go in the favor of relativity theory. by
But
the
you're not
way.
allowed to call him to the podium, and he's not allowed to take it. Like he's not allowed to speak on it publicly. Wasn't allowed to debate it. It's absurd.
And what all this overwhelming specificity does is it brings you full circle back to the main point that flat earthers have been saying since the beginning, which is, well, many of them, that relativity is inadmissible on its face because it's a reification fallacy. like the most concise refutation. It's just like it is fundamentally impossible on its
Yeah.
face.
The only bad thing about that remark is the people who don't get it on his face because they don't get the overwhelming underlying things that go with it are just gonna reject it and laugh outright. So it's like,
No, that's true. Absolutely. Like I am always a fan of substance specificity, obviously, but I'm just saying, like we were correct. Like, haha. Like, of course, the more stones you overturn, the more you find out that it's just complete BS because it's fundamentally impossible, But I guess
yeah,
this is where we're at now. We have to like cliff notes, decades of pseudoscience to teach the ballers as they just check out and act like it didn't happen, I guess.
oh man, that's what I was saying. Like I was like angry. Like when you actually get to the bottom of it, and you like if you watch Alan's presentation 6 times, like I have, to realize like they how dare they lie about these things to claim them as supporting relativity or any heliocentric promoter. All these things are evidence for our side, have been forever, and all they did was like obfuscate, as you said, and turn the thing to a benefit. That doesn't disprove it. Actually, it proves the globe. And they said that for 6 of these things, and they got away with it for way too long, and right to the point where people today will tell us the things on Wikipedia, like we just said, and go down that list and go, nuh-uh. Like, no, you have no
it's
idea.
crazy.
All the other people knew this.
That's the craziest part is that like the smartest people knew it at the time and were very vocal about it, and they still pulled it off. It like makes you think like, what are they gonna say in 10 years?
It's because they didn't teach us what they said. They teach us what they did, right? They didn't teach us what they said about the contemporary times or what the contemporary said on purpose, I think.
Well, yeah, of course. Like, what you think they're gonna teach the quote that Einstein said? If Dayton Miller's correct, my entire theory is garbage. Like, of course not.
Those are so hard to find now.
Yeah.
I do think the best part of that is the quotes you pull from the geocentric stuff, where you just pull all the top level scientists in astronomy, and they go, look, they all support geocentric positions and low key in a etheric background. So,
Well, the ballers have regressed to such a remedial level at this point that they just need repeatable catchphrases to repeat as a script to dismiss anything you do. So, like that, 3 hour in depth presentation I did, their rebuttal to the whole thing is, "Oh, here's what's it cherry picking again." That's literally it. They can all just say it and they leave satisfied, you know? So I'm imagining they're kind of doing the same. They're going to do the same thing with Alan's info. Like, oh,
Oh,
he's
dude,
just cherry picking.
dude, yeah. So the two critiques I got from it from some academic lads, who you know, one of them said that my research was just like opposition research, meaning that I was just trying to like find nitpick or whatever kind of thing. And then the other one, what did the guy say? I can't even remember what other guy said, I'll watch it all and get back to you, and he never did. I sent him like the PDF, the sources, and
Dude,
all that. Never got
that's
back.
the
So
number one response. That's the
the
number one
classic,
response. Dude, academics do that every time. Like, I hate to say it, I don't throw him under the bus, but Professor, or what's his name? Yeah, Rob Parks, that's his name.
That is his name.
Yeah, man. He asked for the papers to show the dynamic equivalence in a geocentric position. I'm like, all right, I got you. I sent it within 5 minutes of the end of the stream in the very same Discord chat that we were talking to get the stream started. Literally, I sent him the stream link there, and then I just jump in Discord a few months later. He's like, "Well, what's it never sent me the papers?"
Yeah.
It's a slow response.
He's a sweetheart, but it's like, yeah, there's like when it comes to that, it's just like there's no real way to combat it, right? Because it's like now we know, right? Like now we know everyone used to believe in a physical or everyone used to believe in a medium that facilitated that was the mechanism that facilitated the energy transfer for all these things, and like that's how it worked. And so like you've now replaced it with an abstract math concept and says that. And you're saying that it's nothing that's doing this, but it's like the concept of time and the space in between the two events. That's like, what are you talking about? So, you're like, yeah, like we now know the trick and that they don't have any supporting evidence of it. And like, that's a wrap, dude, because it's all based on a house of cards.
Oh, that's why I'm kind of excited to see you debate McToon on specifically these three things, like the very specific outline you put out for a debate. Like he has to accept because no one else will do it, and he has to take the stand of the globe, and he's going to offer. I hope will be the best globe defense to any of these points for actual refutation, aside from just like hand wave dismissing the whole thing as they've been doing. I want to hear like the best counter to what we're saying here, as they have to, because you can't have heliocentrism without relativity. So I don't know.
Oh, dude, wait a minute. McToon agreed to what points?
Oh, dude, check this out, bro. Check this out.
Yeah, man. He put out like how it was like someone debate me on relativity. I'm the king. McToon was like, hold my beer. I was like, should I be like, okay.
So you know how Jaron has that debate platform where it's like you have to show up with at least 3 claims and support your evidence and all that. You can't just, do modern day debate type shit, right? It's going to be structured. So I was like, oh, that sounds dope. So I put out a challenge for a structure. This is the challenge I put out. So it says, my position and positive claims, position preface. Throughout the history of interferometric experimentation, the speed of light has shown to vary. Without experimental evidence for the invariance of C, the second order corrections of length contraction and time dilation become unjustified. Consequently, without justification to accept Einstein's postulates and Lorentz transformations, the qualitative mechanism to explain the experimentally measured difference between heliocentrism and geocentrism vanishes completely. By way of reductio ad absurdum, the natural interpretation is that the Earth is stationary with respect to an ether wind. I will argue the following 3 claims in the negative with support to my position. 1, experimental evidence for supporting the validity of relativity theory, general or special, doesn't matter, I'll smash them both. 2, the substantiation of Earth's orbital speed, and 3, the justification for abandoning the etheric framework.
Dude, I want him to substantiate the evidence of Earth's orbital speed very much. I would like for him to do that.
That's blowing my mind that he took that debate, bro. Dude, good on you, my dude. This is pretty hilarious. That's pretty epic.
Well, like I'm not experienced in it, and like I'm a no-namer in the scene, so he probably thinks like it'll be like a layup,
Yep, that's
like I don't think
nobody tell him. Globers, don't
I
go
know.
tell him
I
who
know.
Well, can he
Alan.
not read though? I mean, can he not read? You know,
I mean, I know, but he probably thinks that, like, like, I don't know, like, I don't know.
Well,
No,
no, but he
he must
admitted
think.
that he doesn't really know much about it. Like,
Oh,
Oh,
I
really?
mean,
Oh, well, that'll be
well, I
interesting
mean,
then to
every
see how
time
that
every
goes.
time I've pressed him on like relativity, he's like thrown his hands up and just started spewing tactics. So I don't
Oh,
know.
interesting. Well, yeah. Well, maybe he feels comfortable then because I'm kind of a no-namer, and he's
well,
gonna,
yeah.
like, work
What
it
he's
out or
saying
something.
is that he thinks he knows relativity better than you. Otherwise, he wouldn't take the debate, right? Like, I don't know.
Yeah, I guess
That's
so.
all good.
Yeah, no, it's perfect.
Yeah.
But like,
Yeah.
I remember one time he was like, "You have no measurements of stationariness." I'm like, "What does that even mean, dude?" And he's like, I'm like, "Okay, wait, you mean nothing?" I'm like, "How do you measure
Be a measurement
stationariness?"
of the absence of motion. What?
He's like, yeah. I'm like, "How do you measure stationariness?" He said, "Well, you set, I don't know, set up a test to measure rotation and show that it's doesn't detect anything." I'm like, "Oh, like Mickelson Morley?"
like your boy Ruyong Wang in 2004. What's up? Shout out to
Yeah,
your boy.
he's like, I said rotation. I'm like, yeah, like around the sun. He's like this freaked out, dude,
That's so funny, dude.
because
But
he
wait,
wanted to talk about the Earth's axial rotation.
do they really have any evidence for Earth's orbital velocity? Because that's the big one, dude. I've never even heard anything.
I'll give you the next best one. So stellar aberration is their next one. So we were talking about that the other night from their debate. I was slightly incorrect in my analysis of the distribution of the phenomenon. Apparently, it happens to all stars and planets, the so-called planets or whatever, to a varying degree. And if you take that angle or whatever that it produces for that arc, now they say that it makes a full circle arc or whatever, but that's or or an ellipse or whatever. But if you take that half arc, and you take that angle and ratio it to the speed of light, you get 30 kilometers a second or whatever. So they take that relationship and they say that that's proof that the Earth is orbiting around the sun at 30 kilometers a second. Now, funny story, you know how your boy the Earth is stationary, so it's not axially tilted. So the quote unquote axial tilt of the Earth then defaults to the ecliptic of the sun, where it's just the sun is, the sun's orbit is tilted, right? Makes sense so far?
Yeah.
So if all the stars, if everything in the sky is with respect to the sun, like in the neo-Tychonic model, that observation of the stars showing that aberration and the planets and stuff, it would correspond, like it would show, it would be the exact same. There would be no way to differentiate that between a stationary Earth and everything going around the sun, around being in alignment with that ecliptic, or with a sun going or Earth going around the sun. Like, just the mathematical
Correct.
ratio
Yes,
reduction is just their I don't even want to say a coincidence, because it is really interesting, but it could easily be the ratio of the relative motion between just the stars and the sun, just as easily. So GG.
Well, no, it's like it's a direct equivalence. Like aberrations is a no-go for them.
Yep.
Or neo-Tychonic system easily answers it. I mean, I'm telling you, they have nothing. But this is what's so funny, bro. It's progressed to this point, right? So if I say, does anyone have any actual evidence that's exclusive to the Earth orbiting around the sun? You get crickets. And then I just jump in and say, just so you know, I mean, retrograde, no. Aberration, no. Parallax, no. And like, I'm being very literal. Like, you can't bring up any of that. So they have nothing. So they think I'm just saying it, I guess. I don't know. But like, they've basically just tapped out, like I said. That's why the fact that it's a structured debate, there can't be like interruptions and stuff, right?
Yeah, no, Jaron will mute him. Like, it's structured. That's why I was super into it, because I was like, this kind of format was what I was like looking forward to like get into the debate scene, because the modern day debates are a disaster. Like, people show up and they're like, here's how I want to argue it. I just want to ask questions. Like, what are you talking about?
Apparently, I'm doing a debate on their 2v2 this weekend with John Circus. So you get ready.
Oh, nice, dude. That guy's hilarious.
We'll have to get the panel going.
Yeah.
Get ready for a very well structured Interruption-free debate.
Yeah.
Dude, who did Leaky debate on Terranism with this format already? It was McToon.
Yeah.
I feel like he was being kind of a dick now that I'm remembering it. I think was Jaren reining him in, or
What's that?
was Jaren reining McToon in last time? I feel like he was kind of running over it. No, triggering Brian back and forth, like you said. Is he going to hold him to this format strictly because we would need him? But I don't seem to recall him doing that hardcore to Brian Leakey. So I don't know.
Yeah, so I think there was like
I
some.
think this is awesome if he's going there.
Yes, I think there was like some miscommunication in the structure or something. So that's why he's changing the terminology for like it has to be a claim or whatever. So you have to show up with your claim and then have your supporting evidence. You can't just talk for 3 minutes about nothing.
Yeah,
like not have a coherent point.
I remember that. I remember watching it going,
So-
"There's a flaw in this system." Hold on.
So yeah, moving forward, it will be more structured. And actually, if anyone's interested in debating Brenda debates, Pitch Lumen had to bow out. So Jaren's looking for a fill-in on that. If anyone wants to interact with Brenda,
I have forks in my eyes, bro. What's wrong with you?
yeah. I mean, I just throwing it out there. And Jaren asked
Well,
me.
I'm glad someone's doing it. I guess because I'm not.
Well, no one is now. Like Pitch was going to do it, he bowed out. So.
I mean, I'm glad someone's doing the whole structured debate thing. Like,
oh yeah, absolutely.
Because like McToon, the fact McToon will keep showing up, it's a good thing because if McToon just keeps showing up, getting chopped down, like it'll really kind of mess with the ballers a bit. They're like, damn, dude, our hero is going down.
Well, yeah, because I'm like he's got to be able to offer the best global response to any of Alan's points or any of the actual like refutations relativity because no one else has put anything else forth. So he's gonna come with something, I hope, and then we can herald that as the best that they can offer, which will be laughable.
Okay, well, this is what I think happened. Okay, I think the reason he took the debate is because he thinks he can reach out to a couple of quote unquote experts, and they can kind of give him some things to say. So he just confidently did, like, same thing with FCFE. Remember when he was like, I know you're wrong. I just don't understand it well enough to know how. You know what I'm saying?
Yep.
That's something I can think.
Maybe.
Yeah, that's what I think as well. But it'll be interesting, man. It'll be fun. Looking forward to it.
Well, that's not going to work for him, obviously, because these quote unquote experts can't rebut your presentation either. So
yeah, I mean, but he doesn't know that yet, so it'll be interesting to see what happens with the refutations. But yeah, so I was thinking of doing it this way, since no one even the subject matter is so dense and whatnot, and I want a good show. I was thinking of giving him the questions that I'm going to present, or you know what I mean, so he can like formulate a response to him. Like not giving him the whole argument in its entirety, but like showing him the basic outline of what I'm going to present.
No, that's maybe a good idea because otherwise he'll have the cop out of like.
Yeah, and then giving him the sources as well. Yeah, I'm going to give him the sources as well, so he can.
I think that's a good idea.
Yeah, so it'll be super structured in that regard. So there can't be like, oh, I don't know anything about covariance and transformations. It's like, nah, dude.
Yeah, exactly. You can't just bring up some random topic and expect me to know all about it. Like it gets rid of that.
Exactly. So yeah, I'm gonna craft up a structure for it and then send it over and with the sources, and then he could figure out like how I'm gonna argue it from there. But he'll have all the material necessary to see what I'm talking about.
And then he'll immediately just Google each paper or source and ask Google what's wrong with it, and then repeat those answers.
I hope he does, because you think your boy didn't already do that?
I'm just letting you know. It's perfect.
Dude, it's amazing too, because with the GPS stuff, no one has even presented the arguments that are Googleable. Like everyone's like most people are like, well, maybe maybe the corrections are okay and everything like that, or what was the other one that guy said? Maybe the speed of light's allowed to change or something, like just ridiculous stuff. Like you could literally you could literally Google like a decent refutation to the GPS argument. Well, not even decent, because it's
maybe they're just allowed to change that way, Alan.
Yeah, but you can like literally Google the guy that they paraded around for 20 years to tell everyone that relativity is proof of GPS. And then they could have an actual argument for it. But one day, one day.
Oh, I think they just move away from relativity eventually. I mean,
I
It's dead and
anticipate
gone.
I anticipate some points where they're gonna attack you even at your level. Where do you think that they're gonna that they don't like what where do you think that you have Achilles heel anywhere in there?
To be honest with you, I don't think I have one. I think it's so well rounded. If I'm able to argue it coherently to the best of my ability and knowledge that I have, there's no going back from it.
I think
There's
it's
no out of it.
full blown tactics. I
Yeah.
think it's nothing but tactics.
Yeah, but you're doing the tactics too. Do you think that you understand that subject material as well as those experts that you're citing?
Yes.
Yeah, but the mainstream science doesn't have a reputation. That's why these things are buried, and that's why Dayton Miller wasn't challenged until after he was dead with some weak ass shit where they were like, yeah, but temperature. He was like, bitch, I did 400,000 experiments with temperature, whatever.
Yeah, like
There's a
I'm
guy
telling you, bro,
that
I haven't
says that
found a
that shit's
baller.
worthless.
I haven't found a baller rebut this stuff, dude. I haven't found one. And like when I bring it up to experts, they're like,
Hey, buddy, I've told you that the guy that doesn't like the Dayton Miller stuff, he's told you to look at Robert Shanklin. Another
Yeah.
thing is
I
where
know
you
all about
guys.
Shanklin, bro.
Okay, well, go kill these
I eat
guys.
Shanklin
But
for breakfast.
go kill them. Listen, go kill them, man.
I will.
But I anticipate the part where when listening, where you talk about how they're like to reproduce a lot of experiments. They're like adding variables like arm length, going in the basement and stuff like that. That to me sounds like it needs to be like tightened up. I don't know how else to say it.
No, Dayton Miller already tightened it up. The Shanklin refutation to Miller's work is completely fabricated and based on lies. What they actually did to derive their statistical analysis of his work was they they took experiments where the data just happened to match the diurnal seasonal effects, and then they focused on those specifically. And in combination with that, like it wasn't randomized; it was specifically targeted selections where it matched specifically to derive their analysis of it. And then on top of that, there was data that wasn't even published that was from his control experiments where he was deriving all of the things that I was talking about, how they used the variation to hide the variance of C to make it appear that it's invariant. All that stuff that he figured out, all those experiments and stuff that he did that isn't even published or part of his statistical analysis, they pulled from that to support their stuff. Like it's pathetic on their end. They have no ability to, like if they're going to cite Shanklin, they're in for a real surprise.
well, that's why they won't come in here. That's why they're just going to stay in Jib Pandas. If you want to come in there, then you can get stomped on by 50 people interrupting you,
No.
muting you.
You're right. I'm sorry. I'm talking to you. I'm so impulsed. But yes,
You're
because
straight.
but y'all need to come over there and browbeat them with it. You can't let the final word when a reporter like me come through who can just hear the lie. I can't, I don't have my hands on all this. You know what I'm saying? Shit's over my head. But I can see who's positioned, and we can't let them have the last word. We can't let a majority audience hear me come and be like, oh, well, this side said, and then them, oh, yeah, this, and then that. Like, you gotta stomp them motherfuckers.
Well,
Because y'all know
tell them to come out of their
really
little echo chamber, dude. Like, what do you want?
Yeah, they can debate me anytime on Jaren's platform. Anyone that
They
wants
will
to defend
never do that,
relativity
dude. They
theory.
will never do that.
That's what so come bring y'all's. Alan goes over there. You know what I mean? You go over there. You know what I'm saying? Like,
I don't go over there anymore because they specifically censor the hell out of me, bro. Like it's easy to get the last word when you don't let the other person have a word.
Well, I ain't gonna let that happen. 3, 5 of us, 10 of us can go over there. And I mean, the dude's like, Shanklin, tell Whitson, Don, tell Whitson he's an idiot because of Shanklin. Like, we can't, I mean, come on, man. You think I want to go smack him in the face? I don't agree with the first fucking postulate to this shit, this fucking all frames are valid, and no, because energy in the fucking material. Like, anyway, you know what I'm saying? Like, if something's fucking moving or not. Like, period. Dude,
dude, that's what I'm saying. Like, you think we haven't heard of the first Google results? Dude, like, come on, dude. That dude Googled it, and then was like, I'm going to pretend to be an expert.
Yeah,
Okay,
like,
so look,
dude,
I'll report. So what do I tell
hold
him?
on,
Shanklin was
hold on.
fraud. Shanklin,
I'm gonna,
how do I give me some bullet
I'm gonna give
points?
you the exact paper. You can just link them this when they talk about Shanklin. I'll give you the exact thing and paper to link them, and you can just tell them to read this if they believe in Shanklin, and then if they, if they don't, they can go from there, man. Like if that's their
Yeah,
game-winning
but
argument.
but just so you know, this is what I think. So these people are extremely interested in like our up-to-date arguments, but they like to do stuff like talk to him where he comes over here. So then they have this
Right.
huge buffer where they can like kind of try to figure it out, but they still get to hear the information without actually engaging in the conversation. So they never have to eat crow live, right? That way they can kind of keep up and update and learn, but not ever actually engage. So you
Right,
can send them
right.
that paper.
Come
Give
with
them
me and
that
make
paper.
them eat crow.
Yeah, you could forward them that whole paper. It's an analysis of Shanklin's review, and it breaks down. Firstly, it breaks down Miller's work and goes over that in detail, and then it goes over Shanklin's refutation to Miller's work and how he derived everything and what the implications are and all that. And like you can just go from like that. Like that's it. Like it was a literal hit piece. While Miller was alive, his work couldn't be refuted. They waited 14 years after they died, and then they got Shanklin, Miller's former research assistant, to character assassinate him, with this shoddy work on his analysis debunking Miller. Didn't do a single statistical analysis of the sidereal rotation correlation that Miller found. Just focused solely on the diurnal effects, and then only specific cases where the data actually did match. And then, like I said, he
Okay,
pulled from control data. Like it's just sad.
let me say that again. Didn't do the sidereal, focus on the diurnal, and
No,
then
separate.
is that
So the diurnal seasonal effect plots would be like the temperature variation corresponding to the time of year. So if you're in summer, winter, that sort of thing. Is it hot today? Is it cold today? Is it humid? That sort of thing. And the sidereal effects would be plotted against what's happening with the rotation of the sky, right? Or the so-called
right?
rotation of the Earth, right?
But I'm saying the deception was they just focused on the diurnal. Is that how I say that?
Oh yeah. I'm sorry. Yes. They just on their analysis, they just focused on the diurnal effects where it happened to match, and then they said that all the rest of Miller's work is just a misinterpretation of these effects that we selectively manufactured in to discredit him.
And they be because it's like, man, it's like the overconfidence be killing me, dude. Like, in the side that's
Yeah.
right, if they're right, you can be like that. But if you see both sides, you're like, well, one of y'all motherfuckers is right. You know
Yeah.
what I mean? So it's like, why? Like, what the
Well, one side has like a paper from every single angle, and one side has the first Google result. So I'm just saying.
Yeah.
I champion it a lot with it. I go over there, I say the stuff, I try to stand up for it a lot, but without being scholared in it, like you got to kind of get them to concede somehow through logical agreements, or you got to browbeat them like this, and we got to fight through the muting and the censorship or whatever,
Oh well, I already told like
I know
okay,
they're not worth your
they
time.
came in, they're not worth my. That's right. So they came over and begged me to come back to that server. They offered me mod and all this stuff, and Jim sent his little minions out to keep begging me to come back, and I said no. If I ever came in there, I would go in there with a group of people, like with Alan or something, and we would have to be given temporary mod to where they couldn't mute us unfairly. It's the only way I would ever agree to. I'm not wasting my time with some people that could never fairly debate, just get to pretend they're dominating by like group mentality, mocking and ridiculing and interrupting. It's just such a waste of my time. It's like the kid that can never catch a slant route gets to pretend he's Jerry Rice. Like it's just retarded.
I don't get it.
Look it up.
Jerry Rice really knew how to throw a basketball.
Yeah, I'm telling you. Get a great swing.
Hell yeah, dude. That's what's up. Yeah, I would go into gyms with that arrangement. That would be dope. That's actually kind of what we did on some random public forum. Do you remember when you showed up to that? What's it? Where it was just like me, Shane, Tribune, and a couple other people. and we were just on that server, just dancing on everybody.
Oh yeah, and they were like standing in line one by one.
They were standing in line. Yeah, they sent up the heroes to get smashed. Yeah, it was awesome. But yeah, I'd be down for that, where they can't interrupt, because like that's the worst, right? When someone's trying to Shanklin you, and you're like, well, hold on a second, let's analyze what Shanklin's work was really about, and then they're just like, you can't deal with that, right?
Because this is the whole thing, right? I guarantee you this is what they're doing to down there. What's it so retarded? They're so stupid. His own assistant said it wasn't and they're just laughing. They're just like mocking about how his own assistant did it. And to them, that's game, set, match. There's no reason to even hear what someone says back. So it's like,
Right.
I'm not going in there where they get to just do that. It's an absolute joke.
I asked them to be specific, because, I may be unfamiliar with shit, but logic I can handle. Like, I can learn things. And, I asked him to be specific, and he did hit me with that, like, Shanklin and the confidence. But he was like, basically summed it up to Miller had old shit, and they got the new shit now, and therefore the new shit showed it was. He just was too old and but dusty. That's his fucking summary that he told me.
Did you give him the list? Did you give him the list of the modern replications though? Because what I asked for was like, what specific test does he claim shows that it's zero now? Give me that list, and I'll happily show you what they're doing wrong in each one of them to try to ensure close to zero, and then I want him to rebut the modern list. But they won't. They never will.
Yeah, see,
did
now
you give
that's
him
where
that
it's a
screenshot?
battle. That's where it's a battle.
Screenshot's
I did. The one with the list of all the things. That one.
And did he read them and respond?
It did, and it got to that point right there where it was like he just positions it as you're wrong. That's a list of failures that you're missing. I'm pretty sure I'm doing him justice here. I'm pretty sure that's what he's saying. He's just saying you are wrong. You don't get those. They're not for you.
Oh,
well, okay then.
No. Well, funny story is like they actually don't want them, so they're ours now, and we take the ones that they did try to take, like Sagnac and all that. So we actually own them all.
Like this is what's so easy. We have such an advantage as truthers, right? So it's like, oh wait. We can just get ready to go into a conversation. We don't even have to know who the person is. Like I just have to go to Wikipedia, Nicholson Morley, go to the bottom of the page and look at the list of the quote unquote modern replications. That's all I have to do.
Yep.
Literally, bro. 100%. That's what they're doing there. Because if you go to Mickelson Morley on Wikipedia, if you go to the bottom, there's a chart of the modern test. And they're like, oh yeah, see, it's like close to zero now.
Nice, dude. That's
dude, I've had to do the simplest of things to make sure that we have understand, like the diagrams that I'm telling you. I think it can really help, like whether it's just math formulas or little figures of the material, whatever we're describing, and just get the people to just all agree, and then like put the vote marks. Like anybody doesn't agree, like at least know, and then you can see which items are agreed and which aren't. And then when they try to go back to it, or have their cake and eat it too, you point back, and you know what I mean with things like the invariance, things like the conservation of the momentum, the selective the selective detections. I know this sounds big, but I have a lot of points. I position them all the time with the shit. So I know we have points we
need coloring books. So Alan, what we need to do is create like a Dayton Miller cartoon.
Dude, that's
you know
awesome.
what I'm saying?
Yeah.
Dude, it would be fire, and show like what Dayton Miller did, and then show Einstein over there with his decrepit, half-naked, incestuous self over there, and then being like scared in the corner, like, well, if he's right, I'm screwed. And then like show his assistant, like we'll just wait till he dies, and then all doing the grappler hand rub, and then we'll just like go through the story of what happened, and that way it'll be like a nice 15-20 minute cartoon. And they'll understand it.
That would be so epic, bro. Like that mountain bear guy that does the Owen Benjamin cartoons.
Yes, yeah.
Like, could you imagine a mountain bear like rendition of Einstein, Mickelson, Morley, Dayton Miller, and all these guys?
It'd be fire. Hilarious. That's the future, man. That's the future. Like 10-minute cartoons.
Steelman them too. Do them both. Like paint,
Oh,
like try to
dude.
make it look as best as you
Yeah,
can for them to and see as
absolutely,
it.
dude.
But yeah, the diagrams like help. Like I've had through. It seems like there's verbal possible noise in the communication, and it's like you know guys, what do you predict? Where's the photon going to go? Why doesn't it miss? Stuff like this. We talk about how come the signal's not missing when we send them into space, stuff like this. And half the time it's like they don't sound like they understand it enough to agree. They're like, wait, what do you mean? What do you this and this? And then you draw them the little picture and you fucking nail them to the, cross. So like now they cannot fucking verbally wiggle. You know what I'm saying? They got to pick one or the other, like, I don't know. Anyway, I've had a little bit of success with it. Just want to share a little bit of success.
Yeah, I mean, I'll just go. Like, I have to still set my computer up, dude. But I'll just go to the list of Wikipedia, the Wikipedia list of like the claimed replications, and I'll go through the tests specifically, and then I'll read all the parameters of the test to show what they're doing to basically cook the books. Alan, have you done that?
No, I haven't. But what's his name? Somebody did, or well, Miller did already. So
Well, I mean, like
Ryan already
well,
pointed
this
that
is
out.
I'm talking about like long after Miller, right? Like where they claim that they're doing. If you go to Wikipedia, you go down. There's like all these tests post Miller that they claim show that it's closer and closer to zero as the technology gets more accurate, and that's like the Glober talking point. Like that's the script. Like McToon said that a few years ago, so they all just repeat it like the gospel.
Yeah.
So we should just go to the more modern list and like look into the test specifically. And
Oh yeah, just point
yeah.
out where they did the Miller stuff, or like where they made the Miller changes.
Yeah,
Yeah,
we're
we
like
definitely
yeah.
should. Yeah, because forget who it was. That Bryant Myers guy, he was actually the one that pointed out that there was a tending towards zero pattern or whatever, throughout the history of it, right? And then that was what made that Chris Pastor guy start looking into it. And then when I hit him up when I was trying to learn about interferometry, he was like telling me about all this and the trending towards zero stuff and what Dayton Mill. Oh yeah, Maurice Elias. So what Miller had already pointed out and figured out through his controlled experiments about changing the length and the medium and all that stuff, how it affects it. Um, Maurice Elias in like 2002, when he did his statistical independent review analysis of Miller's work and found that the sidereal rotation stuff was, super valid and accurate. Uh, let's see. He also pointed out that the modern interferometry stuff is tending towards zero, and that the modern experiments are following the methods used that Miller pointed out that would facilitate those results. I'm pretty sure that was Elias who pointed that out. That's where I like got that from. It's like I haven't even looked into him, but like where I got that interpretation from was from him.
It's
Like
a
it's
tough
so
spot.
funny. It's like if Dave Miller's like, yo, you gotta get higher altitude, man. You gotta get closer to the sky. You're gonna really see what goes down. And they're like, okay, go to the basements. Like they're
Yeah,
like they're like the Lord of the Rings character or like a vampire that's scared of the sun or something. They're like
Yeah.
go to the basement.
That's very weird, and it's a tough spot for me to even act like I get to even talk about it, but you got them like changing things, right? Like, okay, well, so what are they going to do? Say, well, if you don't change, if you go back and do the old stuff, like they're going to say, oh no, that's not good enough, and you got messy results or something, but can't you be like orientating this thing in like different ways and still show a bias regardless of how couldn't you show, you know what I'm saying? Couldn't you show bias patterns regardless of how messy
So
your
the
shit was if it's sensitive
so
and can
the
do anything?
yeah, so the effects still persist regardless, like even though they try and change it, right? And then so what Miller mapped out, the significance of it specifically is that fluctuation change corresponding with the season. So like if the sun has to move faster and all that, like that's what he would have been measuring. So like that's what the significance of that would have been.
Right. I'm saying, how can they throw this? Isn't that what you want to do regardless? Is not only just have it running for 10 years, but also having it in the basement and in the sky and in the
Oh
middle.
yeah, well,
Don't
there
they
was a
want it
dude that did
everywhere?
an experiment for 3 years where they left it running. That was one of the most
Okay.
recent ones where they did with like super tricked out equipment where it was like, all up to date with modern sensitivity and whatnot. That was in like 2000, 2006. They left it running for 3 years and they reproduced Miller's work with more
That's
sensitive
why. That's
equipment.
why. That's why I wanted to hear them respond and to the list. And their response is, "You're just wrong. This is like okay, okay."
Oh
Well,
yeah,
is
it's
that list part of the grouping that gives you this tending towards zero pattern?
No, dude. It's the opposite. It's what shows Dayton Miller's results.
Okay.
yeah, so I'll link the list here. So from this list here, the paper by Yuri Galev. Hold on one second. Put this in order. The paper by Yuri Galev, 2001 and 2002, are two different radio interferometer experiments where where he reproduced Miller's work. And then Hector Manera in 2006, in the paper titled "Observations During 2004 in the Periodic Fringe Shift in the Apodynamic Symmetry of the stationary Michelson-Morley experiment." So what that big word means that they invented just means that it was continuously running. So they left a classic Michelson-Morley interferometer setup running for 3 years, and the readings that they got out of it backed up Dayton Miller's work as well. So if you're going to cite people to rip or the
Okay.
reproducibility of Miller's work, hit him with Yuri Galev and Hector Manera.
And so, gosh, it's just so hard to be like, well, look, Group A, Group B obviously shows you that they're doing it right, so stop saying they're wrong. And, like it's.
Well, they're never going to stop, right? Because they can't, because their whole framework collapses under with the admission of this. Like their ability to interpret everything is gone. So
Well,
they
let's
never
talk
will.
about it, man. Let's talk about it. Like, obviously, can we respect the fact that there's like professionals doing stuff, and then they're asserting things, and for whatever reason, it's been exposed that maybe they're what's the best category while they're trying to do all these manipulations and get it wrong? Are they trying to create the desired result? Do they think they're just
Well, it has to be okay.
variables?
According to this is how they look at it. According to relativity, right? Like it has to be zero. So they look at it like whatever they do that gets it closer to zero, that's them doing it correctly, because the correct answer is zero in their mind, because relativity says it has to be zero. So
But
they're doing
shouldn't
whatever they can
isn't
do.
that weird? Are you sure? So okay, so I two parts. Can you respect like all the onlookers' position of like if you're gonna come back, if any of us reporters are gonna come back and say, oh look, they did this wrong. It's dirty of them to do this thing right here. You know what I mean? We're just a reporter, but we're gonna say it's dirty because look, they're trying to lean it in this direction, and this is leaning in a direction for them, so they keep going. Like, shouldn't they just like said, oh, we expect it to be hypothesis, equipment, and then boom. They shouldn't have to like tinker with the fucking equipment. Shouldn't they just set it up how they hypothesized to set it up? Like I
I would
respect.
say if you're going to debunk Dayton Miller, you should probably do what he said to do and what he did. Yeah, that seems like pretty basic stuff. Hey, real fast, Alan. So I'm putting little red boxes around them for Don. What was the third one you said? So I
Yeah.
boxed both Galev.
Yep, Manera Hector, 2006.
Okay.
Galev, Hector. Yeah, it's a delicate position where it's like, if we're the middlemen, but we also understand that this has to be said. You know what I mean? It's like it's so hard to share when it's like because people want to fight against you just for being the middleman. You know, and then it's whatever. We
Well,
should, man. Y'all should go steamroll these guys, man. Y'all should go
think about
steamroll.
how crazy this inversion is, right? Since the relativistic interpretation is already assumed to be true and all that, and it's taught to these people, when they do the experiment and they get a friendship pattern, they're like, they think they're doing it wrong. So then they correct the apparatus to give 0 or to get it to as less as they can, right? Like, because they
Are
think from their
you sure?
perspective that it shouldn't be doing that. So it's like you don't even have to.
That's not science.
Well, no, you don't even have to like nobody's in on it or anything like that. Like these people aren't bad people. They have a lens of interpretation, and they've been taught that you know, uh, certain things about how to interpret experimental evidence and stuff. So when they view it through that framework, like they just use the math to conform to reality or their version of reality to the experiment.
Wouldn't it have things to do with funding also? I mean, it always
Yes.
comes down to money.
Absolutely, absolutely, absolutely. So that's the other big
Don,
factor too.
I put little red boxes around it for you, man.
What's up, Rocky?
Yeah.
Yeah.
If your department is
Um,
being funded by people who believe in this model, right, and you set off and use all their funding to disprove it, you're quickly going to be ostracized or put out or defunded. I mean, that's
Yeah.
just how the world works.
It's just crazy it would even be interpreted like that. It should just be interpreted like we're getting a better, more precise understanding of what's actually happening.
Yeah, man, it's so weird to me. Like, what? Why are you going to fight against it? Science should be all over correcting themselves about the nature of reality, right?
You're
Like,
assuming it's
that's
science,
its job.
though.
Okay,
You're
okay. How about people who are gonna? I mean, okay, if it's not science, it's what? Surveyors. It's people who are
No, that's
telling
not
us
what I
about
meant.
the Earth. I mean, I don't get it.
That's not what I meant.
Okay,
I
but
meant
let's not trample the exact point we're talking. I'm trying to talk about these people tweaking the arm. Like, let's say they go, okay, we need 9,999 titty hairs of length on each of these arms, and we should expect this and that. And they set it up, and then they kind of don't get the thing they thought they were going to get, and it's showing the alternative. Is it? I'm trying to dissect right now. Are they going, oh, well, maybe we didn't have our arms at 99.9 titty hairs. We must have been off a little bit. Is that the type of mistake? Or do they know what they're doing and they're still, like, editing these things? Or, like, how confused are they is what I really want to unravel.
Bro, these people have never even heard of Miller. Like, they're not taught Miller's work. In physics textbooks, it says Michelson-Morley is a null result. Like, they literally have like, most people will say Michelson-Morley is a null result just because Wikipedia says it. In their paper, they never mention a null result at all. And they actually say that they measured the Earth's orbital velocity, albeit at a slower thing. Like, like people just have their own interpretations to facilitate it, right? So,
Alan, go to this link and go down to there's a subsequent experiment, and I took a screenshot of that. But then there's a recent experiment. There's a recent experiment.
So Jews also, so that guy Daniel Grazzari has a really good paper titled something about relativity's failure in the photon sector and its predictions, and he goes over some of these interferometry experiments. So Jews, Illingsworth, and Kennedy all produced a friendship pattern as well. Or yeah, it actually says it here in the thing. Like none of these are proof of anything. Like it's literally.
No, yeah, I'm saying like so. If you go to the recent experiments section and scroll down, you'll get into the 2000s, and this is the list that we should look at, and we should compare them to the. You know what I'm saying?
Oh, is there a new list? Okay, because you linked the old list.
Well, that's the old list, right? So if you go to the I dropped a link as well. So if you go to subsequent experiments, it'll show you like the ones like right afterwards, and then the section right below that is recent experiments, and then it'll still show you like through the 50s, 60s, 70s. Keep going down, and you'll get to like the 2000s. It'll go from like 2000 up.
Okay, yeah, recent. So Wolf and others, Mueller, Wolf, Anatoni, Stanwix, Herman, Mueller. Okay, yeah,
And it says like temperature control, blah blah blah. So like I want to go through these, which I mean I will as well. But like I think that's what we should do, right? Because that's just like the nail in the coffin, where it's like, well, here's all the recent ones that you can't respond to that were done properly, and then here's exactly what's wrong with these. Even if we find just refutations, right? People may have already analyzed the data and refuted it, and we can cross-reference. Not that the nail's not already in the coffin, but you get it.
I mean, I can already see, like, just in the description where they've done things that aren't analogous to what was done.
Yeah, I don't know. I'm on my phone.
Yeah.
It's
A
like
pair
someone.
of rotating orthogonal microwave resonators are compared.
Yeah, dude. Yeah, dude. It's like, okay, bro, cool. And then the other one was 2 optical resonators constructed from a crystalline sapphire controlling the frequencies from the wavelength of this laser are set to at right angles with a helium cryostat. They could be like, they're already just not, so it's all good. Yeah, we should definitely go through some of these.
That's hilarious, dude. They're just like why is this in the Mickelson Morley page?
Frequency of 2 optic resonator cavities are compared. One cavity was continually rotating while the other one was stationary. So yeah, that was actually already done by DeFore and Pruner in 1942 with a circular interferometer, one rotating and one stationary, and they produced, the same variation. So like these guys did it slightly different with different equipment, and they say they got less of a fringe. It's like, cool, man.
Yeah, I'm gonna look through these.
Yeah.
The frequencies of a pair of orthogonal-oriented optical standing wave cavities are compared. We'll see. I mean, they haven't even got this far. I can tell you that much.
Yeah,
Like
dude, I literally haven't even heard anyone mention the modern ones. So
Shankland.
Yeah, that's light work, dude.
Yeah.
All I gotta do is confidently say Shankland, and
His own
they get to
assistant.
pause me for another week, don't they?
Yeah, his own assistant disagrees. Ha 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 ha.
Optical tests. Shamir
That dude
and
sold his soul,
Pons.
dude.
Yeah, that paper you should check this out when you get a chance, because this guy has refutations for a lot of these.
Nice. Oh yeah, drop it. Is it the paper you dropped earlier?
I'm recognizing now. This is one I haven't dropped yet.
Okay. Yeah, I gotta get my computer back up. And I'm gonna like really dive in that. I think if we just like really put all of our efforts together, like you're doing a ton of it already. And like just really iron out every single aspect of this to the point where it's like it just ends the debate. Like the debate just doesn't happen anymore. That'd be great.
Yeah.
You know what I'm saying? Like, cause like this is all I can think of that they would refer back to is like, oh, it's been, cause I heard like McToon said this like years ago, like, oh, it's been doing, and then that's where Bryant Myers got it from talking to McToon.
Oh, interesting.
Yeah. McToon just repeats it because McToon is the Wikipedia master.
McToon is the best.
That's what's up, bro. You pull your skirt down a little bit. Say it with your chest.
Does he think that he actually knows this shit? Like, does he have advanced degree or something, McToon?
Well, no, he has like a mathematical degree or something, does like computer programming, but he knows that if he says it confidently enough, with enough tactics, that he wins in the eyes of the ballers. So he knows deep down that he doesn't actually know. You know, like about this specifically, he knows he can't debate it. So it's crazy he agreed to debate you. I'm like blown away.
Are there any? Do you think there's any smoking guns like, as far as like a pattern or all these, list of attempts to I guess, should I say falsified the Dane Miller stuff? Like, where they're changing lengths of arms and going to the basement, all this, like, are there smoking guns to where we can see that they tried to be accurate and then they got their undesired result, and so then they, like, started manipulating and shifting? Like, is there a pattern of that? Can we see, like, original readings and then see how they're evolving, like,
Oh, that's
within
me.
each team?
Yeah, I mean, you would literally be looking at Dayton Miller and then all of the responses to that.
But no, but I
That's
mean the evolution within each team, like within each one, like
that's what I'm saying. That's why I'm saying I want to go through them specifically. Because you
right,
can't
right.
get a baller to actually invoke one specifically because they've never read any of them. They're just saying talking points. Like that's what I'm saying. We're just going to do their work for them because they're 100% not going to do it. So I wouldn't really know the answer. I wouldn't know. Also, here's the thing, right? Say that they did a test and then they started getting the results that show some type of pattern. They would immediately assume, just like they were taught by everyone else, that, oh, I must be doing something wrong. There must be an instrumental error or something. And they're going to keep doing it till they get closer to zero, and then they're going to publish those results.
Right. But it'd be great if they had a history of that, right? It'd be great if we could uncover record and or pattern history of that.
Yeah, I'm saying like they probably wouldn't even like publish that. But Odysee.
True.
They adjusted leveled on back in the day. If you can find that, the original definition of level, they've amended that.
Yeah, I understand that people want to just be like, look, fuck this group of people because they want to question what the map could be too. But it's like, bless us all who want the truth. Okay, it ain't gonna hurt nobody. Okay, we'll have more food for everybody, and people will be safer when we all figure out like the truth's gonna help us get along. So,
All right, Alan, I'm gonna read these two papers. I'm gonna get my computer up and running, and then we can just kind of go back and forth and kind of iron some of this out, and then I'll show you how to make your presentations in a font that's a readable size. we'll be golden.
Nice, thank you. Well, this was the How Math Met Reality was my first one, so I didn't know. Like, I thought adding a bunch of text and reading it directly was how you communicated with people. So, sadly, I was mistaken in that regard. So,
Well, with information this dense and foreign to people, like they have to go back and look at the slides, and like read them and try to, like we're literally like, it's just as humbly as possible. Like you have to approach it like a classroom, and not that we're like some like above
for sure.
everyone. It just once you research it, it's like there's so much info you kind of have to like really walk people through it and make sure they can get it because it's like a lot.
yeah,
Like,
just
take
the
notes,
terminology
class.
alone is crazy. Like, that's why in all my presentations, I like have a definition slide where it's like, okay, boys, today we're gonna learn all these new words and how they apply.
Yep.
Yeah, people.
It's cool
People
'cause
need
it's
to
actually
respect. Sorry.
Yeah.
No, you're good.
I'm fucking just dude. I'm just peanut gallerying, man. Hit me up. What's interesting, buddy? What's interesting?
Oh, I'm saying like it's crazy that we're in a paradigm where this like freaking mathematical pseudoscience is like interesting. It's like directly applicable to us because it's like the linchpin of a deception that's really big and affects all of us. So now all of a sudden, like the cool kids in class are like interested in like like the specifics of relativity, because we're like we got to get to the bottom of this.
Yeah, I know, man. As a globe enthusiast, I couldn't stand listening to relativity lectures or trying to learn anything about it because it was just like so dense and complex, and like it just didn't matter because everyone already figured out that it was the best thing ever. So I just had like the basic fundamentals and was like, all right, well, I guess space time is the fabric of the universe and it curves according to what some guy saw 40 years ago or whatever.
Nothing's moving, but it's all moving.
Yeah, like I was like totally down for it, just blindly accepted it. It was so fun to go through because I really see the value in steel manning the arguments, which I appreciate that's what you do with your stuff with it, because it's like if you can't argue at the core of it, then it's like what are you doing? You're just pretending, right? So it was
Yeah.
really fun to take that mindset and like learn what these experiments mean to relativists, and then how they interpret them, and like what the actual theory is and what it means. Because like different sectors of physics will have different interpretations of relativity theory, and like the different experiments will mean different things to different people based on their understanding of the math and whatnot, and how they want to live their life. So it's really interesting in that regard. Like if you try to get all your relativity information from a single source, you're just basically adopting that person's belief system, because it's a lot of this stuff is you can interpret it however
Dude,
you need to.
what's funny, dude? So people message me all the time. They're like, dude, what's the secret to debating? Or how'd you get so good at debating? Or like, can I pay you for a Zoom to show me how to debate? And I'm like, no. Like, there's like three main things. It's simple, right? Like one is like study logical fallacies, like just learn them so you're able to spot them on the fly. Number two is like be able to still man the opposition. So like be able to make the argument better than them and concisely, to where it just takes the wind out of their sails. Because now it's like, you said everything I was going to say, but better. And now you're refuting it, and they have a full, like now they're just crippled. And then third is like set intellectual traps. So guide them through that combo. Like know where they're going to go, and then step back a few moves and kind of just guide them into the trap. If you do those three things, like you're going to win every debate. At least that's my. I'm like, nah, dude. I'll just type this out for you, buddy. I don't want you to pay me for a Zoom. But
Yeah, the three line or three rule tutorial on debating and understanding your opponent's position is super important, man.
It's like the most important one, right? Because like if you're talking to someone, like that's why they literally just like come in my chats now and they just troll. Like they never talk about the subject anymore, because it's like I'm in the background of their headphones, like making their argument really well. I'm like, so this is what they say, and then like you just precisely lay it out, and they're like, damn, that's exactly what I wanted to make fun of them for not knowing. Like when you do that, they really don't have anything. So it's I think anyone that's confident in their position, they should be able to still man the other side. And by the way, ballers cannot do that. So you can just ask a baller, like, still man the flat Earth position for a sunset, and all the anti-flat Earthers on the internet will just short circuit. 2023, they can't even do a sunset. Like they cannot still man the flat Earth. So if for true Earth to have a huge advantage, it's just like really be able to still man the globe. Don't take shortcuts, don't straw man it, don't do anything. Just like lay out what they say very accurately, and then point out why it's wrong. And then now you've omitted them from the combo. Now you like all they do is repeat scripts. You don't even need them now. You're like, well, I've played your role as well. That's why I thought about like doing TikTok shorts where I put glasses on and I talk to myself. I'm the Glover with the glasses, and I just go back and forth. Like we're to the point now where it's more efficient to just remove them, because they're just gonna waste our time. So just like learn to still man their position, and then just move forward. The people that actually want to learn and see what's really going on at the bottom of it's going to be like, oh wow, so that's now I have the decision, like, is it this what he just still manned, or is it his critique of it? And they get to decide, so you get it. It's the secret weapon.
Yep.
Like Matthew learns. I was having this call with him one time, and I'm like, Matthew, can you admit that I could be a really, really good baller? He's like, I don't know, man.
Yeah,
I don't think so. Are you here? You're here. Okay.
Yeah, I think you will be eventually.
Yeah. You did also end up saying that, but and then it's like you were like, I don't know, maybe, I guess, yeah, a decent amount. And I'm like, okay, well, just ask me any question. And I think it was you, but you like asked about rockets in space, and I gave like the best Glover answer immediately. Dude, seriously don't know at this point that someone could ask me a Glober question. I wouldn't know like their best answer.
All
And
right, Whitson, I got one for you.
go ahead.
Explain three precessions on the same axis.
Oh, that one's tough.
That's a tough one, buddy.
Okay, I can do two. I can do two of them pretty well, but the third one
Okay.
is just it's magic. I don't know. Like,
and that all correlates to the aberration or whatever as well. These little micro precessions, like no effect there, right? But only through certain effects that need explained through a particular amount of precession on the
and
same
Matthew,
axis.
that's why I won't be coming over to that side, my dude. Because once I get to the bottom of it, like that question right there, I can explain two precessions at once. The third one is physically impossible. So like
How do you
I
do
got
two at once? What's the two at once?
So like if you take a gyro, or you just if you just take one and you start spinning it, right? So you start spinning it, it'll start to wobble, and then you can also get what they call like notation, where like it'll do like as it's wobbling, it'll begin to kind of also move a different way at the same time. I've seen it replicated physically.
Okay.
I can show you a video, and you can see it, and you're like, oh, okay. So
No, it makes sense. I can conceptualize it. I'm with you on two. That's fair.
but you add a third one, bro. How do you do a third one?
Couldn't do it.
It's like I can't even wrap my mind around it.
Yeah.
Yeah, so it definitely can't be physically demonstrated, that's for sure. Because I scour the
Yeah.
internet for it.
Oh, that's interesting that you found at least two. That's good to know.
Yeah, I'll show you the video, yeah.
Yeah, that's tight. But yeah, that third one, that'll get you.
And there's actually
what
more
they-
than three, turns out, so it's like really bad.
Yeah, and it's really, really bad too because it's not like conceptual, abstract. Maybe we're processing at 4 different vectors on the same axis. They actually back it up with laser interferometry. So, like they say that these are happening based on the fluctuations of the speed of light.
And it's like it physically must be happening.
Has to, otherwise they can't explain it.
Yeah, like because like it started with, the stars are kind of moving, and our model doesn't explain it. Like, it's wobbling, and then they're like, wait a minute though, the moon is not really doing what it's supposed to do. Like, okay, add another wobble. We'll just add another one, and then it just kept going. There's 3 famous ones, but there's like more, like the Shannon wobble, notation. I forgot the third name, but I found that there's actually more than that.
Oh,
What'd you
you
say?
found more? I said I think the other one's called the tidal wobble or something like that. Or there's
Yeah,
like 2
maybe.
different types of nutation. There's annual nutation and something like that. But yeah, go ahead. So you found
No,
you found more wobbles, huh?
Yeah, there's more wobbles. I got them
No.
typed up in some notes. Yeah.
Bro, I'm gonna need that wobble list. That's hilarious.
Dude, wobbles are just their get out of jail card. It's like, the sky doesn't match. Just add a wobble, they'll never know. You ask them like, how do I verify? Oh, well, you can't. It's way too sensitive. Like you can't actually verify it.
Only by aligning a multi-million-dollar gyroscope to Polaris can we in the northern hemisphere.
If you draw a pentagram,
Can we measure these wobbles?
draw a pentagram on the ground of blood and then pray it to Einstein, and then you'll be able to measure it.
Oh yeah. Yeah. Sky prophets are dope.
Yeah, it's crazy, man. The more you look into it, it's like, dang, bro, is there actually a claim that doesn't have a problem? Like, I
Or
don't
that
know.
could be like differentiated from an ether theory. Like that was a big one for Purvey because that was the point that Daniel Grisari guy makes, and he's like, by the way, all of these experiments can't be differentiated from classical mechanics. Anyway, I see you guys, and it's like, holy, like, what do you mean? Like these aren't mutually exclusive effects that they're seeing in the behavior of light. Like these are all adequately already explained by the pre-existing framework.
Well, yeah, and in fact, they actually use the pre-existing framework as its foundation for the subsequent explanations, right? Like they use classical mechanics, and then they just like hijack it.
Yeah.
Yeah. And that's what's crazy. That's the real red pill. You're like, oh, not only does it work with the classical wave mechanics, it's like the only way it works.
The only way. So, do you know anything about motion and dynamic motion and predicting motion or anything like that? And like how it has to be predicted from a state, like you have to start off from a stationary reference frame. Do you know anything kind of about that? There's a new thing I'm trying to learn about that's in regards to in regards to the way that they describe motion and velocity and all that and different types of motion.
Oh, that you would need like a stationary absolute initial frame.
Yeah, yeah, it was in
Oh yeah.
reference to like because you know how things are like you can describe something kinematically or dynamically, or what's the other one? Can't remember, but those two different variations. The kinematic description is more like a mathematical, hypothetical, and then the dynamic would be like an actual physical representation of what's
Mm.
going on. So there's not like any wiggle room to like mess around or whatever. And one of the papers that I was reading analyzing Wang's experiment with the conveyor belt situation, and he was talking about the types of motion and the like the and like so you know how we were talking about covariant transformations and stuff like that earlier. So there's a non-invariant transformation that happens when or through the way that he analyzes Wang's experiment, differentiating the absolute rest frame, showing that the effect is with respect to an ether wind, like from a stationary frame. And I was just like, I don't know anything about dynamics and kinematics and stuff like that.
Yeah. So okay. So say you know if you're in like an elevator that drop free falls. If you have like a knitting needle and you rubbed it on like a wool, it'll get like charged up. So say that you charge this knitting needle, right? And then you were free falling in an elevator. If you began to drop little water droplets around the needle, they would start to orbit around the needle. All right, so the little water droplets will orbit around the needle, and that would be the kinematic relationship. Would just be the water droplets are revolving around the needle. So it's just like the geometry, like it's going around the needle, like in relation to the needle, it's going around. It just describes the motion taking place, and then
Yeah. So
dynamics would be it's the electrostatic force that's causing it to move. It's like the cause of the motion.
okay, and then so if you were going to start like a basis to like make predictions of the movement, though, for the dynamic prediction, you would have to start
With the
a
absolute stationary frame.
absolute reference. GG. Okay, so that's what he's talking about. Okay, yeah, so
Yeah.
that makes a lot of sense then. Yeah, dude. So you got to check this paper out too, then, because this is great for um, analyzing Wang's paper and differential. So with Mickelson, Morley, and Dayton Miller and all that stuff, like you could still there's wiggle room to be like, hey, they're interpreting Earth's orbital velocity just at a slower speed. But with what Wang showed, the way that this dude analyzes it with how I was just talking about the different types of motion, um, he shows that it's in reference to like the lab frame, so called, is actually stationary. The way that he did the
Right.
experiment. So I'll link you that.
Yeah.
You can check it out.
Well, they can't do the slower orbital speed though, obviously, right? I mean,
No, 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 no. But like,
yeah, it's
I'm
just
just
a
saying, like,
stick of dynamite.
if they wanted to try and like come back and be like, hey, how do you differentiate that though, like on the real? It's like,
I would
okay,
be like,
well,
okay. I would be like, that's awesome, bro. Please go around and say that. Please go around and say like, oh well,
you're just
maybe the Earth's
orbiting really
orbiting
slow.
slower. Yeah.
Well, no, because the way that you could interpret, well, so they would have to reintroduce the ether, obviously, and this is why they won't do it. But there's models that they could come up with that have like a lesser translation of motion effect, so that they could still have their contraction cake and eat it too, and have the ether, but they would have to go back to the ether to facilitate that speed variation. Yeah, absolutely. So that's why
Oh,
they
but
won't
now they
do it.
have all kinds of problems, right? So, but if they bring up an ether contraction, then that has to show material bias, meaning certain materials would contract more than others,
Right.
but they don't in their model.
Absolutely.
Yeah.
Absolutely, and like, yeah, so that's why they won't touch Miller with a 10-foot pole, and they had to have his former research assistant character assassinate him and then give him all kinds of prestigious awards.
What do you think that dude
after
got?
he did
Like
his dirty
hookers and
work.
blow or something?
Oh no! He got a whole bunch of stuff. James Demio outlines it in his paper. He got exclusive interviews with Einstein. He got promoted to Miller's former spot at the head of some research or at the Case Physics Institute or whatever it's called. Miller was on like the board of directors there, so he stepped up and swooped that position as well. He got some exclusive government contracts. Yeah, he got like he was well taken care of after he did that.
Wow, and some hookers and blow.
And, well, yeah, obviously.
I'll have to read that paper for sure.
Yeah, the James Demio paper was awesome. I'll link that as well after I get the other paper for you. Robert Bennett and James.
Yeah, I have the James Demio paper pulled up because you sent it earlier.
Oh, nice. Okay, so
I
here.
just have them all on my phone browsers though.
Dude, your phone browser has what, 700, 800 tabs?
I have a lot, yeah.
All right. So here I just linked the paper. So that's the dynamic analysis and the kinematic analysis and the invariant relationship shown there that breaks covariance and showing differentiating the effect of a stationary Earth with in a moving Earth, right?
Nice.
What's your favorite paper that doesn't prove the globe? Oh man, that's funny.
It's getting bad out here, man.
Yeah.
But that's why, like, they're like I keep saying this, but their new tactic is actually to avoid the trenches. It's like literally, it's like create an illusory straw man battle and just stay over there.
Yep. Yeah.
That's basically forfeiture. Or like, wait, Kosho can be like, Alan's just wrong.
Well, he's supposed to be doing a presentation on GPS or whatever, kind of refuting some of my points and giving his perspective on how it works and stuff. So, we'll see if that comes to fruition.
We shall. Well, if he does, props to him for at least doing that,
Or at least trying. And just instead of just looking at the source or something and going, oh, this wasn't published at harvard.edu/official sources / backs up heliocentrism narrative / experimental evidence of heliocentrism.pdf. Like, this isn't that. So I can't read that. And it's like, oh, okay, dude. Well, I guess you win, dude. You can't read it. Oh, you win.
No, that's so funny,
selective
bro.
reading.
Yeah, because even whenever that's why I limit most of mine to like Ivy League schools, and it still doesn't matter. It doesn't even matter, bro.
No,
I'm like,
doesn't matter. Doesn't matter. I
Cambridge
used to try and do
University. No.
Yeah. I tried to do the same where it was like, well, this source isn't the best or whatever. It's like now I just read it and like, does it make sense? Is it real? Do they back it up? Like just kind of interpret it for yourself now at this point. And then if there's an experiment or experimental evidence, it's like, is it repeatable? Did someone else do it? And it's like, oh, okay, cool. They did. Well, I guess I believe this guy more than the other people now. I don't care where it was posted.
Exactly. If there's like replicated experiments over here, and then it's just theoretical physics over there, like Why would we go with the one that has no experiment? Because it's like a certain person or a
Dude.
certain associate.
Think about how crazy this is. The Michelson-Morley experiment it took 6 days, and it was about 8 hours in total of measurements, right? That they spent doing actual experimentation and all that. So 8 hours, 6 days. They redefined all of physics for that. And then all the subsequent 30 years of experiments backing up that their first interpretation was right the whole time. Like they were like, no. We've already committed. We've already re-rolled. It's too late.
We've already re-rolled.
Dude, they redefined it after 8 hours and 6 days. They were like, all right, boys, let's pack it up. There's no ether here. They're
That's
still
hilarious.
moving.
Yeah, it makes you think. Like we could definitely orchestrate some pretty damning tests at this point.
Yeah. Yeah, I think just equatorial readings would be a bang out. Like we wouldn't even have to get anything super sensitive or too crazy. Like just good enough to do the job.
Yeah,
Because they
for
don't
sure.
have any they don't have any experiments or showing any correction angles or anything. And they would totally have that if it was real. It would be their biggest. They would be like, look, we have to tilt it to the side. It doesn't get anything because we're a globe. It would be the most profound GG, well played. Hey, it's definitely a globe experience. Like, they don't have it. Doesn't exist.
Yeah, and none of them. When I bring it up, none of them even care. They're like in a different world, dude. They're like,
Yep.
yeah, well, why would they have it? What?
Why would they go to every latitude and map this effect that varies, specific to the latitude? Why would they go everywhere and map that out? That doesn't make any sense.
Yeah, they're like, well, it wouldn't be doing anything, so they just skip that place. Like, I'm like, the real question is, why do you believe it doesn't do anything there if no one's ever shown that?
Yep.
Oh, it's just all the other evidence makes me think that. Like, all right, bro, you do whatever.
The two other examples that I've seen in the northern hemisphere that match planar correction angles to a Polaris, definitely convinced me that we live on a globe as we get further away from that Polaris correction angle situation. Anyway, what are you guys up to? Did you guys catch that sport game?
It's a huge difference too. Like, it's very possible that it's a huge difference. You go far enough out, it just continues. Yeah.
Yep. Yeah, I bet you it never stops picking up a reading. I bet you it just gets stronger.
Yeah, it would be crazy. Like if you just go to the equator, it keeps doing it. Go past it, keeps doing it. It's like, talk about GG.
Yep.
Dude, they're all just evolving. Like even Nate, bro. Even Nate's just evolving. PC pretty gay right now. They're just all they're all tapping out, dude. That's what I'm saying. Why don't you guys just retire? Like what you're doing is weird anyway. Just go play video games.
Wait, are they in VC or are they listening to the stream and then typing in Discord?
I don't know. Yeah, the latter looks like.
Oh, okay. Respect, I guess. Yeah.
I heard you earlier say Mickles Morley, which is two dudes, by the way.
Yeah, dude. Had to preface because some people don't know about that. They think he's the same lad. Did you know that Morley worked with Miller a lot as well? He went on to work with him.
I did not. Edward Morley.
Yeah.
That's
Yeah, man,
dope.
that James Demio paper was awesome reading the history of it. That's where I read about their open debate that they when they got together and did that. I was like all inspired. I was like, yeah, that's awesome. We have to keep doing that.
Yeah, I'm definitely gonna check that paper out.
Yeah, it was epic. Let's see, for those listening at home who don't have time to read the paper themselves, I did a reading of it the other night, posted on my channel, which I'll link in the chat.
Oh, nice. You just read the whole thing?
Yep, just read through it, gave some commentary, throughout. But yeah, it was like I read the first couple uh pages on it and I was like, "Oh, this is awesome. I gotta put this out for people to listen to." Cuz it's such a it goes over Miller's work, and like all the delicate work he did on temperature, controlling all that and all the controlled experiments he did to figure out how the best way to get the ether readings and how to isolate it and all that. And then it goes over Shanklin's work and how, when you understand what Shanklin did and how he reviewed Miller's work and his choice selection of what he, or like how he did his statistical analysis and stuff, just reveals the fact that it wasn't it wasn't a fair review. It was designed to invalidate a guy who couldn't defend himself anymore because he was dead. And then everyone just ran with that, and he got all those rewards after the fact. Like he covers all that in there.
Yeah, it's like all the people, like, say, trying to challenge all these physicists and stuff to debates, and then once, like, with a couple flat earthers die, they're like, then they speak up about what we were wrong about.
Yeah. Yeah,
Like,
no.
now that Witset's dead, let me tell you how wrong he was. Witset's dead,
Yeah.
and we'll talk about it.
Yeah. Yeah, that was the only way
That's
to do it.
cowardly.
And it got to the point where they, because Miller's work couldn't be refuted, so people just, he stopped getting, jobs and people stopped like publishing his work and like being interested in him and stuff, and they just kind of faded him out of existence. So like
Touche.
in the last years of his life, he was like all bitter and stuff because nobody was trying to hear him on his 40 years of experimental proof that Einstein was just making things up. And yeah, it's kind of sad. And then they promoted the guy that lied about him. They gave him his position, dog, when he died. Like it's so sad.
Yeah, it's crazy, bro. That sounds a lot like Tesla in a way.
Yeah, very similar story where you just have an absolute legend that just crushes everything, doesn't give a shit about he doesn't care. He just wants to figure out like what's the best way to detect the thing that they were trying to do, right? That's all he cared about. And yeah, you just see how that was rewarded by the system.
But some dude that doesn't do any experiments at all is, like, famous.
Dude, yeah, that's the other part, man. The guy that never did any experiments. They're the guy who said experiment is king, quote from that guy.
Yeah.
And then and then he relies on there was a couple instances like that quote that you pulled where Einstein was like, "Yeah, if Miller's work is true, I'm toast." Like he obviously knew about it and had no refutation to it. And the couple of times that he did try to refute Miller's work publicly, like in paper articles that you can reference and stuff, he attributed Miller's work to temperature differential effects. So like he clearly had no idea about anything that Miller was doing. Like he wasn't reading. Well, he might have had an idea, but he wasn't going to admit that, obviously. So
Yeah, there you go.
his persona of it was just to act like he had never seen it, the same way he did with Paul Gerber, the same way he did with Lorentz's ether theory with ether contraction, and even used his entire framework and said that he had never thought of, or never seen it, and that he had thought of he had thought of this independently based on him hearing about Michelson Morley and his thoughts on the experiment with a magnet and a conductor. So that
That
was
dude was just
his.
a liar, dude. Like,
Just lied
yeah,
all the time about everything, man.
crazy. Like he first says, "Well, I came across Michelson Morley. It was puzzling." Blah blah. Well, what's interesting is you said something about a secret letter he wrote to his wife. I definitely want to
Yep.
get my hands on that
I'm
and
about
see
to
if there's
pull it
like
up
an
and read it
original.
right now for everyone. We're about to read it.
Yeah, that'd be cool. Because then at the supposedly,
Wait,
apparently
dude.
the
That's
year,
none of
the
our
year,
business. What a secret
Yeah.
is. All right, go ahead.
I suppose apparently the year before he died, he wrote something to the effect of, "I don't think I was even familiar with or had ever heard of Michelson Morley when I came up with special relativity." He said that the
Yeah.
year before he died.
Yeah, he's such a clown, dude.
Such a liar, dude. Like he intentionally lied. People are like, "Oh, maybe he just got old," or no, he's just a
No.
liar, dude. Just like he didn't say Henri Poincaré came up with the 4D space geometry. Like he just stole things and then lied. If someone called him out, he's like, "Oh, I didn't know about that."
Dude, Minkowski fixed his covariant situation by hyperbolically contracting time and space, with the geometric expression of space-time, so that all subsequent transformations would automatically be covariant. And Einstein was like, "Nah, fuck that. I don't understand it. That's gay." And he didn't want to use it. He wanted nothing to do with it. Because he wanted to come up with his own framework or whatever mathematically, and obviously couldn't do it. His wife had to step in and help him, and then they settled on using mathematic logical fallacies to establish pseudo tensors and everything for their framework. But yeah, it's all just gobbledygook.
Makes
Okay,
you think.
so
Go ahead.
go ahead and then I'll read the letter.
Oh, no. Go ahead first.
Good. Okay, let's see here. All right, I'm gonna screen share. 720p should be good enough. In case anyone wants to read along or whatever. This is from Hector Manera's paper, 2006. A man who reproduced, part of a group of men who reproduced Dayton Miller's work with a classic Michelson-Morley interferometer setup, and they over the course of 3 years, they reproduced the Miller's findings, where during the equinoxes, the fringe shifts reach their minimum and maximum dimensions on the day, of course, or in relation to the movement of the sun. So anyway, here's the paper where they talk about Einstein and Lorentz and special relativity and the theories involved. So Einstein occasionally made the statement that he did not know the results of the Michelson-Morley experiment before 1905. Quote, "When I asked him, Einstein, how he had learned of the Michelson-Morley experiment, he told me that he had become aware of it through the writings of H. A. Lorentz, but only after 1905 had it come to his attention. Otherwise," he said, "I would have mentioned it in my paper." So his mathematical theory that adheres to Lorentz symmetry, right, based on Lorentz's ether framework, where the mechanism of contraction and time dilation, or I don't think he dilated time, possibly, but anyway, the mechanism was direction of motion in the ether, and then space-time, the mechanism is no ether, just the motion, and the coordinate system contracts proportionally. Literally same framework, just different mechanisms for the explanation. So here he's saying otherwise he would have mentioned it in his papers. So he would have given credit to Lorentz had he used a theory based on his work that adheres to Lorentz covariance. So let's see here. So he would have mentioned it in his papers, emphasized in his original. This recollection by Einstein, contrary to his most recent documental evidence contained in Einstein's love letters, showing that Einstein was well aware of the Michelson-Morley experiment before 1905, both directly and indirectly, as follows. Indirect knowledge of Michelson-Morley experiment. Einstein read the work of Lorentz by the end of 1901 and in the beginning of 1902, as attested by letter 48 dated in Switzerland on December 28, 1901, where Einstein writes to Malivia, Malivia, which is his wife. I want to get down to business now. I want to read what Lorentz and Drude, or what's his name? What's it? Drude or Drude or something? Druidude. Anyway, yeah, Lorentz and Drude have written about electrodynamics of moving bodies. Oh, his entire paper, 1905, titled "On the Motion of on the Electrodynamics of Moving Bodies." Oh no way! He was studying this. He wanted to get down to business on what Lorentz and this guy had said about moving bodies and electrodynamics. Interesting. Okay. So these books were written in 1895, or these books were written in 1895, Theory of Lorentz, citation 13, and in the 1900 optics book by Drude, the empirical basis for Lorentz's work was the negative interpretation of Michelson-Morley. Indeed, Lorentz was closely following Michelson's work right before the beginning, sending him a correction to his 1801 or 1818 experiment. So the Michelson-Morley experiment, there was one done in 1801 where the apparatus was too sensitive and they didn't get good readings or whatever. So they redid it in 1887 with corrections made to the apparatus where it was less sensitive to environmental effects. So most people don't really talk about the first one as anything. But yeah, Lorentz wrote him in that one and pointed out some stuff. And he also wrote him in the 1887 paper. Michelson cites a couple of quotes from Lorentz, and at the end of it, actually, the supplemental part is about Lorentz's critiques to it. So anyway, evidently, Lorentz continued quite worried about Michelson's negative results, as attested to the letter to Lord Rayleigh on 18 August 1892. Lorentz asked, "Can there be some point in the theory of Michelson's experiment, or can there be some point in the theory of Michelson's experiment which has yet been overlooked? In addition, Einstein learnt about Lorentz's work and its physical basis through Drude's book. The English translation of this book says in the introduction, chapter 8, that the ether always remains completely at rest. Upon this basis, H.A. Lorentz has developed a complete and elegant theory. It is essentially a theory which here represents the emphasis of the origins." So he already came up with an entire framework that adheres to his namesake, right? Lorentz covariance, right? So the relationship of transformations, keeping the laws of physics the same under transformation. This framework was established by him. That Einstein's special relativity theory explicitly adheres to. Direct knowledge of Michelson-Morley experiment. In the same chapter 8, Drude explicitly discusses the empirical evidence, including Michelson's 1881 experiment, in great detail. Well, we'll have to read that later. Didn't know that. And in 1887, the Michelson-Morley experiment in less detail, i.e., from Drude's work, Einstein learned about the constancy of the two-wave velocity in January 1901. But Einstein's previous information on the subject in letter 11, dated to Malayan in 28 September 1998, 1899, sorry. Einstein said, "I read a very interesting paper by Wynne from 1898 on this subject. Wynn's paper describes the experiments related to the detection of motion of Earth's relative to the ether." Oh, no way. The Michelson-Morley experiments is in the list of the 10 experiments with negative results. The explicit.
Whoa! I want that. I want that list. Okay.
Yeah,
go ahead.
we'll get that citation. Absolutely. See, that's why I love going through these and going through the citations at the end, because there's always so much gravy in these. Absolutely. So let's see. So the Michelson-Morley experiment is on a list of 10 negative results. This explicit test is if the ether is at rest, then the time of the light ray needs to travel back and forth between the two glass plates must change if the plates are moving with the velocity of v. The change depends on the quantity v squared times a squared. A is the reciprocal of the speed of light, but should be observed by application of interferometry, or but should be observable by the application of interferometry. The negative result is incompatible with the assumption of an ether at rest. Oh no way. The the assumption can only be maintained by means of hypothesis that the linear dimensions of a rigid body are altered by the motions of a resting ether in the same ratio so as to compensate for the lengthening of the path of the light ray. End quote. Hence, Einstein read about the negative interpretation of the Michelson-Morley experiment as least as early, or at least as least as early as September 1899. Foregoing new evidence casts serious doubts on the conventional view propounded by Holton. The role of Michelson-Morley was minor in the genesis of special relativity theory. It is clear that Einstein knew, at least since 1899, that according to experimental evidence, the two-way speed of light was independent of the direction, and such a fact necessitated appropriate physical explanation.
Wow, that is fire. Dude, hit your boy with that paper.
So that's your boy from Monera's paper.
Okay.
Yeah. Did I already send you that one or nah? Not sure. I'll send it again.
No, let me look at the 3 I have.
I just sent it. But yeah, a little historicity of the fraudulence of that, man. So if we remember back to a couple hours ago when we were learning about the perihelion precession and Paul Gerber, a man who 17 years prior to Einstein's solutions used the exact same equation under a different mechanism. And then Einstein comes along and uses Paul Gerber's equation under a different mechanism and just completely co-opts his work and says that the perihelion precession is a relativistic effect, even though mathematically it was equivalently described 17 years earlier under Newtonian dynamics and an ether framework.
Wow, dude. This is crazy. And then it says it has a list of 10 experiments trying to detect the motion that were all negative.
Yeah, I'm about to go look those up real quick. So let's see. That was citation. So Wynn's paper, citation 16. Go all the way down here. Bottom. Hit up your boy 16. Oh, cool. It's in a different language. No worries. Your boy has an AI that'll translate it. Let me just find it and then it'll become ours.
Yeah, I need that too, man. See. It was so funny is too when you look into like the Germans, it's like they were strictly ether physics. So it's like Einstein was just real deal an outcast. He had to get out.
Yeah, well, they ended up, using his fake framework as a shield to hide actual physics and obscure like real effects as relativistic effects that have no physical meaning. Because Germany was one of the first people to stop academically critiquing or put a gag order on academically critiquing Einstein from like 1921 or whatever it was. I'm sure you've heard of it, the 1,000 authors against Einstein or whatever kind of thing. So there's it's actually 3,000, and there's like different papers and excerpts and articles that people wrote in and submitted to their respective academic publishers at the time, and they all got denied. But there's a big collage of it. I have a PDF of that as well. I can look for. I can't remember the title of it. I was reading it the other day. But yeah, it's like 3,000. They shut it down in like 1921. They were like, you can no longer critique Einstein, boys. They stopped publishing it.
Wow. Wow. Have you ever heard of there's a book called SS and the Bell or something like that?
Oh yeah, I've heard of that as well. I think that's an ether physics book as well.
Yeah, there's an entire section about how they applied ether physics, and that's how they got successful electrographite propulsion devices.
Yeah.
Referred to as UFOs.
Well, they were super into ice cosmology as well, especially in like they were like if you were if you were like agreeing with relativity theory like in like World War II, like they would be like making fun of you and shit, for not believing in the ice cosmology that they came up with. You can Google it. I can't remember what it's called. Just Google like Nazi, ice cosmology or whatever. I'm sure there's a Wikipedia of it. But they were basically saying that like everything comes from ice crystals and vibrations, and it was like very ether and ice water related. Very vibrational oriented, and they would be like making fun of people that believed in gravity and shit. It's hilarious. Like they had a whole campaign for like how to socially shame people out of relativity and promote their ice cosmology and stuff.
Yeah,
They were
world
all over.
ice theory.
They were all over the place, dude, over there. And then they ended up saying you can't critique Einstein, and everything is right. Like it's crazy.
That's a trip, dude. I'm reading this right now. It's crazy. It says world ice theory or world ice doctrine is also known as glacial cosmogony, a discredited cosmological concept proposed by an Austrian engineer and inventor. According to his ideas, ice was the basic substance of all cosmic processes, and ice moons, ice planets, and the global ether, also made of ice, had determined the entire development of the universe. He did not arrive at his ideas through research, but said that he had received it in a vision in 1894, published a book about the theory in 1912, and heavily promoted it in subsequent years through lectures, magazines, and associations. World ice theory.
Yeah, very cool stuff. But obviously scientifically disproven by the Michelson-Morley experiment in 1887.
Yeah, that's a trip. Dude, I'm definitely going to read these papers. I need to probably crash, actually, but but
Yeah, I'm
dude,
gonna head off too. I'm gonna
you're
find
the
those
man.
citations and get those translated, and we'll have that list allegedly.
Yeah, no, awesome, bro. And if you want to just telegrams, and I got
Oh yeah,
these 4 papers pulled up, dude. I'm gonna look at them, and then we are definitely we'll reconvene. I'll get back in the loop of
yeah,
things.
yeah. Let's hopefully we can reconvene before the 10th because I want to get that kinematic and dynamic relationship down so I can argue it for the stationariness of for the stationary interpretation of the ether wind with so.
I got you. Have you seen the papers I have on that?
On what?
Like the kinematic and dynamic equivalence of a geocentric position.
Oh yeah, I have them or they're on your one Telegram. I haven't like read them personally, but I know where to get them at.
There's one by Luka Popov, and it's pretty short. But the other one is Relational Mechanics by Andre Estes. It's really long. I'll have to find the citation. Yeah, dude, shoot me whatever you got on Telegram. I have these 4 papers pulled up, and then we'll definitely talk soon.
All right, cool.
Yeah, thanks for all the info, bro. This is fire.
Yeah, no problem. Well, you were the catalyst, man. So thank you for grinding, man.
Yeah, of course, man. Team effort. All right, dude. We'll catch up soon, brother.
Yeah, peace.
All right, later, Marcelo.
That was pretty fascinating.
Thank you. Yeah, it was a pleasure, man. Thank you guys for being here. Thanks for staying for that lengthy presentation. I know it runs a little long and it's super dense, but it's all good. It was fun
Great
to
job,
learn it and
dude.
present it. What's that?
Amazing. I said
Yeah.
amazing, of course. I have to go back and I couldn't stay for the whole thing, but I'll have to go back and check it out. And probably the conversation afterwards is even better. Witsit left already, huh? I was going to mention to him something about the conversation with Danik earlier, the dynamic and kinematic equivalence
Yeah.
is like kind of also a misnomer because the globe doesn't have a dynamic, right? They don't include the
Right.
dynamics. That's the whole point that Michael goes to. So I don't know
Oh
about
yeah.
equivalent.
Oh wow,
I
that's
don't think
really
they.
yeah, okay. Dude, so a lot of what you're saying is making a lot of sense now in relation to how that Robert Bennett guy is arguing it. Okay. That makes a lot of
Michael
sense because
Brunner, you
it's
mean?
like no, I'm different source.
Oh,
Yeah,
different.
link me the
Okay.
Brenner stuff that you're talking about though. I'm gonna read up on what he's talking about with it as well.
Yeah, there's a couple. He mentions it in the several of them. The one I always post is like the first column of the one I'll send you. Like biggest scientific mistakes or something like that, or biggest mistakes in science. And yeah, it basically says that kinematics and geometry are mathematical sciences, and dynamics is where the physics come in, and they don't even
Oh
include
wow.
that in any
Yes.
of the
Yes, you
physical
okay.
models.
Yeah, that's basically what Bennett was arguing, and I didn't like, I was like, oh, okay, I guess, but yeah, okay, it makes sense. Yeah, so he was saying, yeah, so when you're doing predictive modeling for dynamic or for motion, but for real shit, you start with that stationary reference frame. Yeah, so that's what he was arguing then. So there is no kinematic equivalent, and that's interesting.
Well, there's no dynamic equivalent. They have the kinematics and they have the geometry. So the kinematics shows how like the
No,
everything
I'm
in
sorry. Yeah,
motion.
how it would actually be modeled dynamically doesn't they
Yeah,
can't reflect it. Okay, yeah.
you have to use real forces and real masses and how the dynamics where the actual physics come in. But the globe model doesn't even use the actual physics that uses they can't, and they have to
Oh,
ignore the
dude.
centrifugal force.
Well, see, okay. Well, that makes so much sense. Sorry to interrupt you. That makes so much sense with Witsit brings up that one paper where they do the orbital velocity mechanics or whatever, for everything for satellite launches and all that based off of a stationary non-rotating Earth, like a geocentric perspective and stuff. It makes sense now because they're trying to have a predictive model of the fluctuation of gravitational potentials and or whatever, right, to guide them through to the next gravitational potential so that they can be in alignment and orbit perfectly. So to even get the baseline for that model, they have to have real stuff to model it out. They can't do it like a kinematic solution wouldn't be meaningful if you're going to have a bunch of
No,
men's lives on the line.
right, exactly. And so
GG.
I
Okay.
look into what he's talking about, and he keeps repeating that there's a kinematic and dynamic equivalence. That's the quote or whatever. And I know he understands what Michael Brenner's getting at too, and he's made the same point himself that the dynamics aren't included. But I'm wondering in that paper how they justify saying that the globe model or the heliocentrism has a dynamic um, quality to even be equivalent, right? Like that.
Yeah, no, that's an interesting argument. Understanding that now, yeah,
Uh,
they don't have. Or Matthew learns. Are you aware of any kind of what we're talking about? Because this is kind of math adjacent, right?
Yeah, I don't know enough to be able to comment well enough about that, so I'm not sure.
Gotcha. Yeah, it's interesting.
it might be another case of we can't create a model.
Dude, that's a whole different dude. We could use that argument if that's how it works out. That opens up a whole different uh, venue for arguments.
Yeah, because Witty keeps saying, well, doesn't it seem like the geocentric model would be more viable, seeing as how it's equivalent in the kinematics and dynamics, but it doesn't require that you have these assumptions that the heliocentric model has to have, right?
Right. Yeah.
But if the dynamics is also an assumption that they even have an equivalent power, then it's even worse for them as a problem. But it might be another case where they say, well, we can't orbit planets to show you the dynamics. It just works the way it works. It works obviously, even though we're only using math to show how it works.
Right.
Experiments, because it's just like the case with anything like gravity or whatever. The only example they have is things falling to the Earth with mass attractive mass, but they can't show it. They can't get outside the system to show the system. That's probably their excuse to what I'm saying. That would be the go-to, I imagine. But yeah, check it in that when you look into what he's talking about. That was fascinating, by the way. What you were, I don't know if you added on because I never caught the first presentation you did completely.
Which
But,
one?
Your presentation, right? Your, how math became reality, like the history of it and everything. So great for people to have in their people, flat earthers should. That should be like required viewing for flat earthers that are, starting to like, get into these arguments because it you can see. I mean, what's so fascinating about it with these guys that are in the Royal Society and these guys that were coming up with these quote unquote proofs, and now and then you let up to where they're like now showing gravitational waves and doing fake clapping and then admitting it wasn't a real thing, that they had to like still look for it, and then it was like anticlimactic. And how long back was it that they really knew the difference, right? It seems like now they're all like, oh, okay, we just have to keep up the narrative. But how long ago was that going on? Like, did Dayton Miller really think we were going around the sun? Did your guy Wang? Well, I don't know. I'm suspecting that maybe
No, Miller modeled it out. No, he did. I'll show you. Hold on one second. I'll show you exactly what Miller thought he was measuring. Yeah, he was a absolute sun lad. He just thought they were
Oh
measuring
man,
it
that sounded
at a
gross
slower.
when you started it like that. I'll show you what he thinks that he measured. No, I'm just kidding.
No, that's funny.
He was one of the deceived instead of one of the deceivers. But they're back in that Royal Society. There must have
No,
been knew better.
so he
That was
just thought that they were. He just thought that the
heliocentric.
translation of motion of the ether was slower, that the orbital velocity and all that was still true, but the way that he mapped out the fluctuations reaching their minimum and maximum dimensions corresponding to what he thought was Earth's orbital velocity. Look at what he mapped out. I posted a picture there. So like, how it's the globe tilted at different locations relative, to a stationary sun as it's orbiting to produce the seasons. Like that's what he thought he measured. Yeah, of the Earth's of
Don't you think
motion
that's
because they
due
all.
to him? Don't you think that's due to him? Just like the idea that they would all like the people that his predecessors and the people that maybe he was still reporting to, that there could be somebody up there that really got it to this point that knew better. Like that idea, like the flat Earth idea, wouldn't even enter his mind still because it was still too crazy to consider, even for him. Even though his data kind of showed that probably is the case, or at least maybe.
Well, they weren't even on the flat Earth grind at that point. The difference would have been between heliocentrism and geocentrism.
Right,
So,
but those were two. That was a false dichotomy, and before that, I mean, it was all about keeping people on the ball, whether it was
what do
geocentric
you
or
mean that's a false dichotomy? The sky is moving or we're moving. They have to explain.
because it's a
Like
ball.
it's to explain an actual phenomenon, right? Well, it
No,
doesn't
you're not
matter. Like
on the
well,
ball.
okay, yeah, okay, I see what you mean. False dichotomy for that, but yeah. So in regards to what they were trying to establish, though, the motion or not, which is the axiom of, or both centrisms, right? So heliocentrism, the Earth has to be moving around the sun, and for geocentrism,
Right.
the sun has to be moving around a stationary Earth. So yeah, they all thought that the Earth was moving, and that was the correct interpretation. So like the stationary result, like that's why a slight fringe reading would give the interpretation could be interpreted that the Earth is stationary with respect to a slight fringe reading, but they were trying to interpret it as the full orbital velocity, and the translation of motion was just lesser due to XYZ factors. And I've seen various ether models where they have different vortexes hitting the Earth corresponding to its alleged rotation with the orbital velocity and stuff, like how it would potentially model out with a stationary effect. But yeah, with the stationary Earth and a moving ether, it explains all of their effects equally, but they never talk about that because it just gives too much validity to geocentrism.
Right. Ewar does a good job in his. I don't know if you ever watched his "What on Earth Happened" series. He did the Boston History of Flat Earth, but he also did one before that. That was like more flat Earth one-on-one type stuff. How we got to this. And one of the things he points out is that they gave us this, like the ball, geocentric ball or the heliocentric ball, and they're happy to have us fight that out as long as we're on a ball.
Yeah.
Right.
Yeah, absolutely. Yeah.
And so I'm wondering, what I'm getting at is like, how far back did it go? Because it obviously got to this point because it was being steered in that direction, not necessarily because everyone involved really thought that it was going on, but because the people that knew better were making sure that that's what they thought.
Yeah, it's really hard to say. So with what my boy Absolute, who comes on here sometimes, that's the name that he goes by, Absolute. Through his research, looking into the history of the almanacs and celestial navigation and stuff, he found that whatever one of the first almanacs or whatever they talk about, the king is basically putting out a bounty for mathematicians to go out on these observations with these ships and come up with a way to explain elevation angles for two observers that match the coordinate system that they were proposing for the globe. And if you could come up with a way to derive that so that multiple observers can see or can take their readings and still be on the glob, he was offering the rewards beyond your like wildest dreams type shit, like the way it's worded, and that old timey stuff. Like you'll just be, compensated beyond all belief and, blah, 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 blah. Right. So they were like they were trying to figure this out back then. And then when you get into the supplementary corrections to the ephemeris and nautical almanacs and all that, or nautical ephemerises and all that stuff, um, again, the funded by the crown, they they lay out the whole framework for it and all that stuff, and you go over the history or they lay out the transformations and stuff, and you see how they derive the heliocentric model from a geocentric perspective, and it's just a coordinate system transformation to get what they needed, and they already had their lat long system set up for the globe, right? So they just went around taking correction angles, and then using they're using their flattening uh, correction equation to flatten or curve whatever they needed to make the observations fit the new coordinate system.
That's interesting.
Yeah, so it's
Which, yeah,
like they're like so when people are like, oh, when you're navigating on a globe, or when you're using a map, you're globing on a map or whatever. And it's like, yeah, but all that stuff was derived from people that were like trying to explicitly make a globe happen when they already had ways of navigating that weren't globular. And,
right.
So I don't know, like,
So there's
the
benchmarks that are interesting to look at. Like when did
yeah.
they decide it was geocentric and a ball? And then when do they go from that to like, oh, maybe we can get them to think we go around the sun, and if we do this reverse engineering, we can do it. They had to be like aware that they were reverse engineering it at that point. They couldn't just be mistakenly thinking we're going around the sun without any evidence for that whatsoever. These guys are, smart.
I mean, the evidence from that time though, like think about the technology and stuff, right? So the evidence would have been mathematical predictions and calculative predictions and stuff like that with stuff in the sky as the evidence for it. And they would have said things like, this can only be explained by the Earth's motion, like shit like that, like shit we hear now. That doesn't mean anything. And but they would have taken that as like, oh yeah, okay, like that's the best we can do now. That's all we got. Like that would have been their proof though. So you got to kind of understand or kind of give some leniency to what they believed and why they believed it.
Right, but and maybe so, and maybe my bias because at this point it seems so obvious as well as you as well.
Yeah, dude, it's hard to look at it through the past and go, how did they not see it? It's like, well, different technological advancements, different framework, different experiments that we now know about hadn't happened yet, kind of stuff. So there's
Right.
different, the best proofs possible would have been like, oh, no way, somebody modeled it out based on the Earth's movement. Cool. And
Well,
then
with the
like,
3959 and all that, like the sky presentation that
yeah.
they did and everything. It seems like they got the right number because of the numbers they had already, and that they must have known what they were doing. It seems like in some points, like, oh, okay,
Yeah,
so they were taking
yeah.
an observation and then saying, oh, it could be the curvature if we say that, and even though there's tons of contradictions involved with it, they still had to go with it, which doesn't make any sense for people that are really trying to figure it out instead of trying to reverse engineer it to make people believe it.
Yeah.
right? So that's interesting. I mean, you're never going to find out necessarily who did and didn't believe it, but I suspect that there was a few at the top that knew the whole time, and that secret knowledge was passed on through the top ranks over time, where it became privileged knowledge to know better from the very start. That line of information that must have been kept, right? Had to be. I think.
Yeah, absolutely.
Eratosthenes, sticks in the fucking ground is good enough, really, for these
So,
guys. Come on.
so I linked a book there from 1924 where this guy goes over the history of globular sailing. He's a flat earther, and he's going over the history of it in 1924 between globular sailing and planar sailing, and he points out a bunch of so basically when they were putting forward the glob maps and the corrections and all that, and this is as late as 1924, right? That people were like, "What? You mean it's a globe? Like, what do you mean you're transferring all the maps to globes and all that stuff?" So when they were making all these corrections, their maps and stuff were off because they were they have to change the distances in the south and whatnot to conform proportionally to hit or to meet the globe, and then some stuff in the north as well. So what they were finding, especially in the South, is how off their stuff was, like just insane degrees. And they would get into accidents. They would hit stuff where other people had marked, like, hey, this area is dangerous. And then, the next people couldn't find that area. Like it was all off. Like it was just a mess for years and years. And there was even instances where like royal, like British Admiralty sailors and stuff, or captains were being tried for wrecking their ships or whatever, but then they were able to prove in court that it was due to the maps, being off. That they, these new maps that they were using that proved the globe and all that actually caused them to be in the wrong spot and all that stuff. It's a crazy story. It's a pretty easy read too. It's not super complicated. It reads pretty easy. And then there was also the matter of circumnavigation, right? So a lot of people say that Magellan proves that the Earth's a glob or whatever because they circumnavigated on the glob, but you can also circumnavigate on a plane. These guys point that out, but the big difference between globular circumnavigation and planar circumnavigation would be on a glob, you're going straight because the Earth's a globe, and at the equator, I'm sorry, at the equator, you would just be going straight if you're going to circumnavigate around the globe. And on a plane, you would still have to, turn or whatever to correct to meet the turn. So this guy interviews the three top prestigious schools for celestial navigation in America, and he writes to them proposing a question about uh, circumnavigation and what the boat what you would have to do. And all three schools had different answers, and then what the one school even sent a guy to talk to this guy in person, the guy who wrote the book, and he gives the account saying that yeah, basically, like we teach everyone that in theory you go straight, but obviously you make the corrections out in the field, and like that was pretty. I like that's
Yeah.
like GG. That's like GG, bro. So you
Yeah.
teach everyone that you do this thing, but in practical reality, you're gonna correct to always be basically relative to the North Pole. So if you're going east or west, uh, whatever side of the ship, you're going to be correcting relative to the North Pole. Basically, you're going to be doing correction
Mhm.
angles to that essentially, and like that's the actual answer, and that's what you
That's what
do
I'm talking
according.
about. Like, just
Yeah,
like the fact that's the way that it had to be. Like, somebody had to make the
yeah,
decision to be like,
yeah.
okay, this is the way we're going to teach it, but the reality's different. Just like we're going to tell all the pilots to treat the Earth as stationary and level, even though it's spinning.
Well, yeah,
And
yeah.
it
At some degree, like yeah, it was
works.
obviously somebody had to know or whatever, right? And then,
Yeah.
but then after you've got your people you're just like, okay, you're going to teach it this way, you teach it this way, and you teach it this way. Don't ask any questions, and we'll give you all the funding you ever need. They're like, okay.
Yeah.
It's like how like does it really matter that much? And like you could come up with reasons like, hey, we have to teach it this way for XYZ strategic military to in case anyone
Yeah.
decides to do XYZ, they're gonna think they live on this and they really live on this, or what I mean? Like there's reasons you could explain it to the few people that would have to be in on it or to accept the offer, You know what I mean, so to speak.
And they might
And
have
then
just been
and then from that, you're just teaching it to people who are like, "Hey, I went to school and I learned the thing and I do the math and it calculates and we're
Yep.
on a globe."
It's so brilliant, so well devised, and so intricate, and it has everything to do with knowledge and secret information and all that. I mean, like the Lorentz transformation is a great example of that. Like, you think that they really thought that it was like the transforming, you know, like it was actually a device
Well,
alpha stretching.
well,
They
no,
think they
there was a
really thought
lot of
that.
there was a lot of resistance to it at the beginning,
Yeah,
but
Lorentz,
through
Lorentz was
but through
resistant.
faking experiments, right? They were able to come up with like, "Oh my god, relativity just can't lose, guys." Every experiment ever just conclusively proves it. You know?
So ad hoc and so like what do you call it, unfalsifiable that
Yeah.
there seems like there would be guys that wouldn't. Obviously, they had to have the guys in place that were just gonna do what they were told. The yes men, right? Yeah.
Yeah.
Yeah, it would be interesting if we could ever find out some of these other guys that have. Oh, by the way, that GIF I made of all the books that one video had, were any of those books the ones you lost?
No, not at all. No, I
I
haven't
don't
read a
know.
single one of them.
But
But no,
well, I mean,
none of
the
those
ones
were it.
the
But
ones you threw in the trash, you didn't recognize any of those titles.
no, it wasn't any of
Oh,
those. It's a real
so they're
shame.
even more obscure, huh? No
Yeah.
way to find those again.
I mean,
Because they're recording now. They're deleting a lot of stuff or making it really hard to find stuff more and more. It seems. Right?
yeah,
We
it's
got
hard to
to
find stuff, dude. But yeah.
So
Alan, can I
yeah.
ask you a question?
What's up?
What's up, Alan?
What up, G?
When is your next debate? Just curious.
On October 10th, McToon graciously accepted my debate offer.
I
So
heard
on
you kind of. I
October
Nice.
kind of
10th,
heard you talking about that. But what was the debate over again?
let's see.
I just heard what you saying. You were brave to take that on.
No, the McToon was brave to take it on.
Oh,
So it's a debate on, with specificity on the, structure or whatever, right? So you're bringing three claims to the table, at least three claims, and then you're supporting evidence, right? So what I wrote out was, I'm not going to read it again. I'll just link you the thing. You can check it out.
Nice. I remember watching your last debate on modern day debate. The
Oh,
effort
modern
you put
day.
in,
Yeah.
the effort you put into your presentation, and just to notice how these globers are just numb. They don't get it, and the way they just disengage.
Yeah. Yeah. It could, like, their eyes just
That
glossed
was
over as
funny.
soon
That
as
was funny, man. It went over their
yeah.
head, and they just couldn't grasp anything, and just like, you know what,
Yeah.
I'm out.
Yeah. She was like, maybe bubbles explain everything. And it's like, oh, sweetheart, that's not what explains anything. But yeah. So I was looking for like a more structured approach to do it, and then Jaron was, was starting his debate, or wants to do debates on his channel, wants to host them with more structure and stuff, so that things like what happened at that modern day debate don't happen. Um, so yeah, I put
So,
this
so,
challenge out with specifics.
so will it be on Jeranism with you and McTune?
What's that?
Will you be debating MC2 and Jeranism outside?
Yeah. Jaron will be hosting it and moderating it, and I'll be debating McToon.
Yeah, that's cool, man. I think Jaren is the only one that really humble fight the flat earth. Today that Jared pointed out that because he keeps saying that I've been navigating for 20 years
Oh yeah.
to Antarctica or whatever. And can you imagine being navigating that long and you don't know east and west is circles?
Yeah.
That's hilarious.
Yeah, they do. Well, they don't teach us that, right? Because if we knew that, then like stuff like circumnavigation would start making less sense on the glob.
Yeah, that's cool. I'll be looking out for that debate anyway. I was wondering when will you and Austin team up?
Say that again.
When will you and Witsit team up for a debate?
Oh, when are we gonna team up? Yeah, I mean, dude, that would be awesome to have like if we had some real solid opponents, like some real People that know the material, like that would be so dope.
Yeah, but I want to be with someone who can argue though. Not, sorry.
Yeah, yeah.
The
It
best
would
they
be a
got is
waste
McToon,
otherwise.
really? Is that really the best they got? McToon and who else? To fight the flat Earth? Really? That's the best they got. Matthews would do better than both those guys.
Well, to be honest, at least Fight the Flat Earth concede sometimes. My tune can't be wrong ever. So good luck with that.
I never heard him.
Yeah.
Sorry?
I never heard him concede. That's interesting. I have to find that.
It just did a few weeks ago with when we pointed out. Well, Jaron pointed out he was talking about East and West. He was trying to debunk David Weiss, saying he was counting all the wrong David Weiss mentioned and saying David Weiss was wrong about East and West being circles, and Jaron called him out. And he put a poll on his chat. He put a poll, and even his members, his subscribers corrected him. That's when he conceded and said he was wrong. But how could you be wrong if you were navigating for 20 years? Were you going north to south only? You never go east to west.
Dude, he's that north-south navigator, bro.
Yeah.
That exclusive north-south there.
So he came out conceding about that.
Yep. Go ahead. That's good. He conceded at least. Well, he couldn't. Well, he had people on his own side calling him out. That's the only reason he did it.
He put a poll on his in his chat, and even his subscribers strangely pointed out because they never like claim to be wrong.
Yeah, that's a mistake I've been pointing out for a long time. In fact, with even flat earthers saying, like, when the idea of Southern Stars come up, and Huey or whoever else would be like, don't all the stars move east to west? No, the stars don't move east to west. They move either clockwise or anti-clockwise. That's the actuality of it. Or you can't, westward is clockwise, eastward is counterclockwise. So it doesn't make that. I don't know why that ever was even a thing. It's obvious, right? It's the circles. But maybe flat earthers would try to avoid it because they don't want to talk about the Southern Stars.
Yeah.
Another particular thing. Interesting. Well, hopefully your structure of your debate with McToon will make him have to concede a little bit too.
Yeah. Like I was saying earlier, I'm going to actually give him the questions and the source material, like the references, so that he can like familiarize himself with what I'm going to be presenting, so that he can actually have refutations to it. So it's not just like I show up with like shit that he's never heard of, because some of it I'm sure is right, like covariance and stuff like that. Like most people don't know anything
Probably
about that.
I can find an excuse not to do it.
McToon is full of tactics. That's the thing. He has loads. He's like a fish covered in butter. No matter how you grip him, you just slide out. He's full of so many tactics. Seriously, you have to be careful of. For example, there's one I was arguing with him about atmospheric pressure, and it was like the atmosphere. I said you cannot use the very thing in question in your premise, and he just won't get it. If you're gonna,
well, he's not gonna give you that one because that just takes away everything. But I get what you mean.
Yeah, he will just keep on saying, he will keep repeating it and bring it back, and to deflect, what he will do, he will go to his super chats. I have a super chat, it's also to like distract you, full of tactics, man.
Well, that won't. Hopefully, that won't be able to be applicable in Jaron's format, right? So, if he tries to do anything like that, it's going to get muted, or have to actually have a response to the stuff, So hopefully it'll work out.
If Jaron leave the super chat for last, that would be good. That would be it's one of his escape boats. So
he's not going to interrupt the debate to read super chats, bro. He'll be at the end.
Yeah, man. I'm looking forward for that one. Honestly.
Yeah, awesome, dude. Yo, what up, Model Builder? I see you in the chat, brother. What's good?
Nice.
Hi. How are you?
I'm good, brother.
I was just about to actually message you, Bottle Builder, and send you Alan's presentation he did earlier today on this channel.
Yeah, I have seen your MP. Just I have struggled understanding you. You have a problem with your mic.
Oh yeah, my mic sucks right now. I knew that. Sorry.
No problem. Just I want uh, to speak about the Tesla things you show me in MP. You know the laser thing. Understand me? No. Yeah. So yeah. You sent me a GIF with SpaceX Starlink trail.
Yep.
So for me, it's fucking fake. Fake at all. Yeah, I found the original video. I will show you.
Okay.
I
good.
found the original video, and we clearly see that at first the dot is too much perfect circle, so it's not Starlink. It's only CGI. It's only CGI, and when you see the beam, you cannot see an infrared beam red on camera. You see it purple, not red. So it's another red flag. And the last thing is when we see Starlink being less brighter because of the shape of the globe Earth or I don't know what, the beam is also getting less bright, which is a nonsense because we should not see a diminish in the brightness of the beam.
Yep. Yeah, they just put a filter gradient over it. It just fades into it as it
Exactly.
gets further away. Yep.
Thank you. You understand. Thank you.
Yep.
Yeah,
Yeah, look
I
at
was
it. It's a
wondering.
uniform gradient, baby. Look at it, dog. Digitally imposed in all its glory.
No,
I thought
it's
you
fake.
might be the person to ask about that, Bottle Builder. That's awesome.
Yeah, Starlink is seen from Earth. Now, so are they claiming though that they seen that laser beams are not visible to the human eye because their wavelengths are not the digital cameras can
Yeah,
capture the
it's
wider
okay.
range of length. Oh yeah, so they're actually saying that they did capture it. Wow.
This is true. CCTV camera is able to see infrared light, but I will try to find a true video. Remote control on CCTV. You will see we see it as purple light. Infrared is shown as purple on video. Northern Rebellion. Just stop. Breathe.
Yeah, so it wouldn't even be recorded in that color. Yeah.
Yeah, exactly. I try to find it's not easy things to do. If I cannot, I will do test myself on my phone. Remote control IR on camera. Maybe like that.
What are they trying to say they're doing there with the infrared or the light? Is it just showing like the perfection of their coordination, or what would be the reason for the interchanging of the lights there between the two strings of Starlink?
I'm really sorry, I did not understand the full question.
My mic sucks. All right.
Oh, dude, check this out. This guy makes a good point. So, in the comment section there from that video you linked, Model Builder, it says the first Starlink satellites equipped with a laser cross link were launched January 2021, at a year after this video. No lasers here. Lasers fired in the vacuum of space are not visible. does not matter if it's a UV ray or infrared,
Exactly.
visible,
You're
green,
right.
or red, or taken with the camera or not. A laser
Yeah,
fired in a
you're right.
vacuum is not visible.
To be being able to see the laser, you need to have some particle in the air for the laser to be reflecting into your eye. Wow, it was hard. Sorry. I will try to reformulate. Yeah, it's invisible because there is no dust in a vacuum of space.
Yeah. Otherwise, if you looked up, you would just see a giant beam of sunlight across the sky. You wouldn't see a single
Exactly.
focal point. The sun would, because the sun's 860,000 miles wide, and the Earth is a little baby.
I don't know how to share a YouTube video from timestamp. Where is the menu to share? Oh, okay, it's good. So here is an example of IR on remote testing. So we see that the camera is showing purple light and not red light.
Yep. And not in a vacuum either, too, huh?
Yeah, exactly.
Yeah. Just up there
Oh, yeah.
propagating their laser light show in a vacuum, dude. That's awesome. So actually, either this video's fake or Starlink's fake. We have to decide which one, guys. Oh,
Oh, I guess Starlink is not fake. Maybe there is a satellite for Starlink. You know?
Or if the vacuum of space is fake.
Yeah. The Starlink being
Yeah,
in orbit.
dude. Do we use this as proof of a medium and just co-op Starlink and say that we wouldn't be able to see the propagation unless there was a medium? Hey guys, this is a great ether video. If anyone's interested in proof of an ether, here's light propagating in the so-called vacuum of space. We can see the illumination clearly. If there was no medium present, there would be no beams of light. So I rest my case.
Either it's not fake, it's a proof of ether. Either it's fake, and it's a proof of space being fake.
And
It's proof of so many
meanwhile, we
things at
know
once.
that both are fake. Both things aren't real. At least to some degree.
It's a win-win situation.
Starlink, by the way, isn't fake. There's something up there in a string. There's a string
Yeah.
of
I agree. I have a friend who is connected to Starlink. So I have seen how the antenna work, and the antenna is always like maximum 45 degree from the horizon, never straight up. You know.
So how do you think they're doing it?
I think there is some relay like a satellite and some maybe some tower, and the antenna is just locking to the beam, the maximum beam. It's you need only 3 antenna, in fact, and with power of the signal received, you can triangulate the emitting point, and you can rotate your antenna to be able to have a better signal. I am sorry if it was not understandable.
I sometimes go back and listen to what you said again. I have to admit, but I think I got what you said. Basically, satelloons that are connected with string, basically like some kind of they couldn't just be flying in that straight of a line without something connecting them, right?
Yeah, exactly. We don't need. They don't need a lot of. It works. How to say? Starlink is maybe more satellite-based communication.
Okay. What about drones? What about like a drone system?
Oh, maybe. But I can only guess. So yeah, it can be technically it's not impossible. Yeah.
Right. Yeah, it seems like there's too many real sightings of the Starlinks for it to be satelloons, because the satelloon might be visible, the balloon part of it. Maybe some kind of drone technology would be more, if disguisable. I don't know, but that's interesting. What do you think they're using them? The Starways. So what are they actually using them for? Is the question, and why? When you couldn't hear me before, I was wondering what are they explaining in that. I haven't looked at the official video that you linked yet, but what's their reasoning for the infrared beams exchanging with the other string of light of Starlinks? What's their the claim there that they're doing that for with the relays of the infrared beams? Like why would that be necessary to do that?
I don't know. It's allergy test. The video it's allergy test of communication system by infrared, but really I don't know because it's not even logical. It's not even logical because you have the shape of the Earth that is blocking you the IR, the infrared, at some point. And on the video, we see the communication is ongoing only on closed paths.
Gotcha.
So it's a nonsense because we have already without IR, without laser communication system, we have already a really good communication. Only with a wireless system. So there is no need for a IR system because it's you don't even imagine the complexity of the laser pointer to be able to lock precisely to another satellite.
Yeah, it would be ridiculously complex if it was
ridiculous. It's ridiculous. Because just put a fucking antenna and it's okay. You put a Yagi or maybe more complex antenna with a huge game, and you have a selective beam, and you only have to be centered on your beam, and it's okay. You have the communication.
okay. So you think so they're if they are satelloons and they're actually doing some of the things that they say real satellites are doing, like it's not just a light show. It's not just to claim something that they don't really need.
Yeah. I'm pretty sure a lot of satelloons are useful for some stuff. My guess is the majority of satelloons are only for data harvesting, like just a peak of the Earth or so on. But there is some satelloons for communication. Yeah.
Sure. Okay. For
And
the claim is that you'll be able to get to like areas that weren't accessible before, right?
My guess is satelloons are useful for GPS too as a relay. Just